Hello everyone, uh, and welcome to all the participants for the presentation round for Digital Alpha's High Prep event. Uh, we have the first team, Team 2. So, the participants from Team 2, if you could raise your hands, I'll give you speaker rights and then we'll go. Okay.
Yes, yes, yes.
Okay, so team two, I see four presenters. Okay, five. It's five. No, it's four. So are you four only going to be presenting the solution? You can write in the chat box.
Uh, so, uh, I've sent an invite to a person, but he did not accept yet. So,
Okay, cool. Arun, we can start, I guess. You can accept the team to the stage.
yeah, I'm doing that. Just giving them presenter rights.
Okay, cool.
Hello everyone. I think all the presenters are have been given presentation rights, so you can present your screen, and I'll brief you regarding the process that we'll be following. So we have a slight change. Instead of a 5 minute Q&A round, we'll have 10 minute for Q&A, but then the presentation timing will still be 15 minutes. So after 13 minutes, we'll sound a buzzer that will sound like this.
Okay.
Okay. Okay. So after that, you are expected to wrap up your presentations in 2 minutes. Going after ahead, I mean, if you cross the deadline, then there will be penalties. So after that, we'll give 10 minutes for the judges to interact with you for the Q&A session, and then we are done. So you can try presenting your screen and checking your mics if you require.
Arun, I see that I'm still an attendee.
Okay. So I'm removing you from stage and I'll add you again. Just a
Okay.
minute.
Okay.
I think two of the members
Also,
from our team has not been added. Uh, could you please look into
yeah,
that?
so Mohawk is your teammate.
Mohawk and Rishabharya.
Okay. Arun, so can you look into it, please?
Yeah. I'll do that. So can one of the team members clarify which team member is still absent in this? I mean, from the presentation thing, from the uh, okay, Rishabh, Arya, and Mohak Gulati. Okay, fine. Fine, we'll do that. So this is for team two. I'm clarifying again. The presentation is for team two. Only those people should be there on the stage now. So I'll give the rights to Mohak. Just a minute. Okay, now is the team done, or is anyone left?
Swaroop is there. We're waiting for Swaroop to be added.
Oh, okay. Sorry. Yeah. I forgot about him. Just a minute.
Right, and Rishabh Arya.
Okay, so Swaroop Nath, I have invited him to the stage,
And Rishabh Arya.
and yeah, doing that. Done. So you can try presenting your screen now.
Sure. Can everybody see this?
Yeah, your screen is visible.
Yeah, it's visible.
Right. Okay.
So I'll mention when to start. You start at that time, and then from
Sure.
that, 15 minutes will be counted.
Right.
Has Rishabh been invited?
Come again. I've sent him the thing. Rishabh
Okay.
Arya, I've sent him the invitation,
Okay.
but then I'll send it again. I cancelled and I'll send it again.
Okay.
Yeah, he has already been sent an invite.
Okay. He says that he can't see the invite. He was on the table with us, actually, table 3.
Will Rishabh be presenting or he'll just be speaking?
No,
Like
but
we
he should
can.
be here for the Q&A. That's all.
No. Yeah, that's fine. We'll hand him over the mic then if he raises hand.
Okay.
Right. Okay. That's fine. Let us know when to start.
Okay, okay. So you can start. You can
Rishabh,
start in. Yeah,
can you raise your hand? Like we'll admit him right now. Like we'll hand him over the mic.
yeah. Just to check.
Rishabh, can you please raise your hand? Yeah. Okay. So we have handed him the mic.
Okay. Thank you.
Okay, you
Right.
can start now.
Okay,
Okay.
so
Hmm.
yeah. Let's start in three, two, one, go.
So getting stock recommendations from Reddit comments is obviously small brain behavior. Reading SEC filings is slightly big brain, but it's very tedious. Having a computer read SEC filings for you is genius. But the pinnacle of big brain is not only having the computer read SEC filings for you, but also having it summarize them into actionable insights. We are team 2, and at the table today we have Swaroop, Aditya, Lakshman, Rishabh, and me, Mohak, from our team. And today we're going to present our novel product, GatherFin, an online dashboard to help professional investors make informed and deliberate decisions with ease. So, from the challenge that was in front of us, we identified two fundamental problems to address. So, of course, SEC filings are abundant and they're a reliable source for investor information, but they're extremely tedious to parse. And secondly, they don't offer the actionable insights that investors need right away. You have to sift through lots of jargon to actually get to the relevant information. So, having identified these problems, we started looking at opportunities where we could come in. And we see scope for a digital product that's free, that's open source, it's easily extensible, and one that's capable of summarizing financial jargon into real key insights. Our design philosophy while creating this product was entirely rooted in two aspects of user experience: simplicity and efficiency. We conducted preliminary user studies to understand our target audience of equity portfolio managers better. And based on our study, we expect users from semi to professional levels of experience to engage with the product, whose core priorities revolve around efficiency, accessing actionable insights and data summaries, while dealing with low cognitive load. So our top competitors in this space would be investing.com, Screener, Money Control, and Tickertape. But we are confident that we can set ourselves apart, of course, by virtue of being open source and easily extensible and lightweight, but also with our unique features for company comparison, the fact that we can extract non-tabular data using OpenIE, and we can gauge sentiments through our sentiment analysis. And we will get to each of these in the coming segment.
Hi panel. So this slide presents the most basic feature of our product is that searching for an organization. So you put in 3 characters, either of the ticker symbol or of the organization, and our code will search it for you and give you the recommendation. And then you can go to the overview page. Moving ahead. So this GIF shows the comparison, the different metrics of an organization at different time frames. We start at 2 months, and then we can move it back to 2 years, 3 years. How much ever data is there in the backend. So you can see that the graph changes and it shows trends across all those time. Moving ahead. So this is another key feature of our product is that we can add 2 companies into a bucket, a so-called bucket from the search screen itself, and then we can compare the 2 companies. Now, how are we different in this space? We don't present just tabular data to compare 2 companies. We also show graphs which have been historically very, very well correlated with ease of understanding and intuitively understanding things. So we present it in that way so that people can easily understand this. Moving ahead. Yeah, so this is the main overview page of our product. When you search for an organization, you will land here. Now, once you land here, you can see a lot of things would be displayed. The company summary, you can see the sector in which the company operates, the market capitalization, and net revenue, price per share to earnings per share sort of ratios, and a lot of other things. Moving ahead. Now, this is a novel part that we have done in our product. What we do is that we don't just sift through tabular data, we also sift through textual data, and through the feature that Mohak mentioned, open information extraction or OpenIE, we extract key question answers that are insightful to the investor, and we present them in our overview page also. Moving ahead. Yeah, so this slide shows the sentiment analysis feature of our product. So what we do is that based on different categories, positive, negative, litigious, interesting, based on these categories, we show what is the proportionality of different kinds of words that are present in the SEC filings for a particular organization. And based on that, an investor can take a decision. Okay, moving ahead. So now comes the backbone of our entire product. We get the data from SEC filings, which are either in HTML or XBRL format. What we do is that we use an external Python library called SEC API. So it's a simple Python library, easy to use. We use that to parse all the data into JSON files. Now, what do we do with the JSON files? Let's move ahead to see. So we use the JSON file in order to derive various metrics. So I have categorized these metrics into various kinds. The first kind is the metric that are already available in the JSON file, such as assets, liabilities, revenue, profit, loss, etc., etc. Now, based on these values, we can also derive other things such as EBIT, EBITDA, ROCE. So we call them derived metrics. Now, coming to the other kinds of derived metrics. Now, there are some derived metrics such as share price to earnings per share ratio, which cannot be done solely based on SEC filings because they do not contain the current share price. So for that, we use an external API, Yahoo Finance, and we gather the share price of all the organizations and we compute the ratios. Now, what other thing that we present is that 52-week high low and the current share price. We believe that every such product should have at least these 2 values. And since these 2 values are not directly available in the SEC filing, we scrape them using Yahoo Finance. Moving ahead. Now, we use Fast API for our backend, mainly because it's lightning fast response to asynchronous requests, which would be very, very good for the deployed product in order to search for a lot of data from the backend. And in order to store our data, we use MongoDB, which is streamlined for JSON files, and that has been our driving factor to choose MongoDB. Moving ahead. So comes the one of the novel parts of our entire product, open information extraction. So what do we do here? We extract question answer pairs pertaining to what? Pertaining to detailed information which are present in the textual data of the SEC filings, not just tabular data. Moving ahead. So this pipeline broadly describes our OpenIE working. What we do is that we take the document, the SEC filings, we extract key financial entities such as monetary terms, let's say assets, intangible assets, revenue, etc. Based on those key entity extracted, we generate phrases using a Python library called Spacey. Now, from these phrases, using simple rules that work automatically on a Python script, we generate questions, and now these questions are fed to a pre-trained Hugging Face question answering model. Now this question answering model generates answers and gives a probability of the answer. Now we sort this based on the probability score that is given as key value pair. Now what we see in our preliminary experimentation is that the probability of the question and answer correlates very well with the amount of information that is present in that particular key value pair. So based on that probability, we do a simple post processing, we filter out those values and we present them on our overview page as we have seen. Moving ahead. So these are two examples. You can see that what is amortization expense to amortizable intangible assets. So you can see that these are things, these examples are things that would be of interest to investors. May not be for every investor, but it definitely would be of interest to investors. And so we believe that such a OpenIE pipeline is very, very essential for such a product. And this is one of the novel things that we have done as part of this product. Going ahead. Now comes the sentiment analysis part. Now, how do we do the sentiment analysis? We extract some particular items of 10K and 10Q, say item 1A and item 7 of 10K, for example. What we do is that we simply segment them into sentences, these paragraphs and these text. We tokenize them into words, and based on these tokenized words, after removing the stop words like is, you, he, she, and stuff like that, after removal of them, what we do is that we compare them with the standard gazetteer that we have gathered from other published papers. Now, what this gazetteer does is that it bins particular words into particular classes, class such as litigious, class such as positive, negative, etc. Now, based on this binning, what we do is that we find out the proportion of particular words, positive, negative, litigious, etc., and we plot the chart that we had shown a few slides back. Now, based on these plots, what we do is that we also compare the similarity metrics. What are similarity metrics? Over the entire quarters or the entire years, the SEC filings of an organization might or might not change. Now, as per our literature survey, we see that based on this change, the performance of the also give similarity indices that can be seen in our web page. Moving ahead.
Right. So having looked at some of the key features, we have identified a few weaknesses in the product. So the product in its current state does not show relative sentiment analysis between two companies, and the information that can only be obtained through manual entry has been omitted due to time and resource constraints. And then with respect to threats, an organization with the resources to capture finer and more contextual data from multiple sources would have an upper hand in this case. But having said that, the product has a lot of strengths. It's obviously a time saver compared to reading the SEC filings themselves. We can compute sentiments even if the text contains financial jargon. We are able to generate user-friendly question and answer pairs. The interface is clean and clutter-free, and the product itself is built using the latest web development frameworks, making us very agile. In opportunities, while we believe we've addressed the semi to professional user segment, there lies scope to build more creative data visualization tools for the financial experts who would wish to deal with much finer and more nuanced comparisons. Accommodating this segment was a bit of a trade-off with our current target audience for now, but I'm sure we can find ways to include this smaller segment of users as well in the future. In conclusion, we've seen how GatherFin streamlines several inefficiencies that investors had to deal with and allows access to the sentiments which were previously buried in raw filings. Additionally, the user experience has been tuned to be intuitive and productive. We see great potential in GatherFin. It's been deployed and is currently live. And we believe this product could enhance the way in which the average equity manager or investor makes the ultimate decision. That is to invest or not to invest. Thank you.
Thank you, panel.
Okay, so if the team is done with the presentations, then we will have a significant amount of time for question and answering. So for Q&A, the time starts now. So, sir, you can go ahead. Rajesh, sir, you can ask the queries.
Okay, thanks, Arun. Thanks, everyone. Thanks, everyone, for the good presentation. So, quick question. In terms of the processing, collecting the data, and the universe of tickers that they gave you, were you able to collect all the metrics? Like, for example, there are standard metrics, like you were showing, that are readily available in the financial statements, and there are certain metrics that you have to extract
Yeah.
from the textual portion of the filings, right? So can
Yeah.
you talk about like both the standard metrics that you extracted from XBRL, what kind of methodology you followed to extract them out, and then the textual version like the ARR, MRR, or CAC, if they were available in the textual filings, how did you go about extracting them? Like even if you used IE,
Yeah.
just want to understand like what is the success rate and all that.
So we have qualitatively measured the success rate of our OpenIE because it was a pre-trained model and we used in a zero-shot setting. We could not really test it because it was directly deployed for working on a pipeline. So in the initial papers, they say that for financial documents such as 10K from the Edgar database, they have had a success rate of 86.84% in gathering key insightful data. So this is published in the paper. Now coming to our analysis, we have qualitatively looked at what can Mohak, if you can go to the OpenIE example.
Sure.
Yeah. So coming to the part that we have done is that after extracting this, we have qualitatively looked at what kind of things we have extracted. So at times, things like deferred revenue, how much of the deferred revenue is still yet to come. So things like this might not be readily available in the table, but somewhere in the notes to consolidated statements, they would have mentioned it. So things like that we have gathered. However, if you're looking for directly things such as customer lifetime value, I'm not sure that we have extracted them, primarily because in our first literary survey of the SEC filings, we saw that customer data was not readily available to us. However, we have extracted things like subscription cost and subscription revenue that organizations are gathering. Does that answer your question?
Yeah, it does. Just a follow up to that. One is like out of 120 company universe that we gave, like for how many companies were you able to find? What is the statistics in terms of, let's say for 50 companies we could find
Okay.
LTV, for 70 companies we could find CAC, that sort of a thing. And the second thing is the numbers that we're seeing here, 95.9 for the amortization expense to amortizable intangible assets.
Yeah.
Um, like what was the accuracy in extracting these numbers from the textual data?
Accuracy was 86.84%. So that was reported by the original paper, which we imported in our work. That was the accuracy figure, 86.8.
Was it was that benchmarked against, like, I'm just trying to understand
Yeah.
how did they arrive at that 86%? Because there are so many things that can go as metrics in your textual filings, right? So
Yeah.
what is the pool of metrics that they use to come up with that 86% accuracy?
Yeah. So what they did is that the basic metric calculation, what they did is that they manually annotated some amount of data as evaluation or test set. And when they annotated it, after annotation, they calculated the full match with respect to the answer. Let's say 95.9 million is the full match, but the model does not predict the million part. It only predicts 95.9. So that is a partial match. So based on the exact match and the partial match and things that could not be recalled, based on that, they have given a formula in the paper based on which they compute the 86.84%.
Okay, and these reference papers are somewhere in your report, right? It's in the.
Yes, yes, in the reference sections.
Okay. Cool.
Yeah, coming
I'll.
to the second question that you had asked, actually, what is the fraction of organization that we could cover the data? So for EBIT and EBITDA, we calculated that in the short amount of time we had. So out of the 120 organizations, we could actually do it for 104 organizations because there was a variability in terms of the way that people write in SEC filings. Let's say net income, someone might write it net income, someone writes it gross income. I'm just giving an example. So based on that variability, we could cover 104 out of the 120.
Yeah, but those two metrics, those should be readily available in the standard SEC filings, right? We don't have to
EBIT
go to
and EBIT and EBITDA.
the. Probably those things you might have to EBIT and EBITDA. I think you should be able to find in the income statement. No.
We had to derive it actually. That was not There was not direct mention of that.
Yeah, but probably the things that go into EBIT and EBITDA that are
Yeah,
readily available in the
those things
income.
were available, but due to the variability in writing that people employ, the recall was not up to the 120 mark.
Even if you use the XBRL, because XBRL has the standardized.
Yes, even after using it.
Standardized. Okay.
Mostly it was standardized. Like mostly we would see statement of income, but in some cases it would go to statement of comprehensive income. So such kind of variability was still there.
Okay. I'll come back. If
Yeah.
any of the other judges have any questions, I'll let them ask.
This great presentation, guys.
Thank
Sorry,
you.
one
Thank you.
second. This is Mahendra. I do have a couple of questions, if I can ask. Could you talk a little bit about the sentiment analysis?
Yeah.
Yeah. Could you detail a little bit what is a positive sentiment, what is a negative sentiment? I noticed that on your sentiment tab, you basically, if you can maybe go to that tab or that presentation right here.
Yeah.
How would me as an investor,
Hmm.
how would this help me make an investment decision?
Yeah. Should I go ahead with the answer? Hello.
Yeah, go ahead.
Yeah. So the basic thing is that we had done a literature survey. So in that literature survey, what we saw is that some papers actually come up with a very crude rule-based system. Is that they take a dictionary of words that if these kind of words are present in a particular SEC filing, then probably in this section it means a negative thing. So let's say in a very generic scenario, I love this movie and I hate this movie. Love and hate have a positive and negative connotation to that. So in financial terms also, those dictionary had those uh, embedded in them the connotation of positivity, negativity, or litigious nature. So based on that dictionary, we saw that how many words lie in which dictionary, and we simply did a proportion. Now, how would that help you? Is let's say there is you see that this particular thing has a bit high amount of positive. So we say that the fraction of positivity in the, let's say, the risk factor section was higher than the other organization, which we say that is a part of our weakness, as we would present it if the product gets a chance to grow. So if we like compare two organization and see that the positive fraction of words in Microsoft is larger than positive fraction of words in an organization, let's say HubSpot, we can say that Microsoft is doing better than someone like HubSpot.
But if you okay, I understand. So it's basically you're looking for the occurrence of words that may be positive or negative, considered positive or negative, or maybe implications of something risky,
Yeah.
correct?
Yeah.
Um, but
And
what if you're like someone like Tim Cook, who generally is a little bit more reserved during his earnings report? He's not usually the outright most optimistic person. Have you
yeah.
considered that depending on the company, um, they may purposely be downstating certain things? Like, how do you factor that in? If I told you, if I said to you that it may not be always about positive and negative words. Like, is there any sort of learning algorithm based historically, let's say, on a number of positive versus negative words? Or have you considered this, how
Yeah.
a company has actually performed historically? Like,
Yeah.
have you tied the two together to validate that these sentiments actually do make sense for me as an investor?
Yeah, so in the tab, as you can see, there are two things,
Mhm.
lexical and similarity. So in the lexical part, we present the static data, what is the probability, what is the proportion. In the similarity part, what we do is that historically, how the company has done, how this fluctuation has gone ahead. So that fluctuation might be aiding your question.
Yes,
Let's
that's
see.
right. Where is that? Can you tell me where that is?
Yeah, if you go to the, I'm just putting in the website. If you go to the gatherf.in website in the chat,
Uh-huh.
you can probably see to the sentiment analysis section, the similarity tab.
Okay, I see what you're saying. Yeah, I'm here. Got it. Okay,
Yeah.
good. Um, the other question I have, thanks for that answer. In terms of the question and answer portion, where you present certain questions and you try to answer them by mining the SEC
Yeah.
filings. Where did you get the list of? Is this an API that you're using, or did you guys implement this yourself? Is it?
No,
Go ahead.
sorry, Mohak, I guess your screen presenting went off.
Shall I present again?
Yeah, I think. Someone else started.
So, are you there?
It's all right.
Yeah.
If you're presenting, we can talk. We can talk to it. Um, but yeah. So my question was, with regards to the question and answer, is this an algorithm or a learning algorithm that you created, or is it a general API that's out there?
So actually, what we did is that, coming to the point, what we did is that such a model has already been trained and published. Actually, this is a very recent publication. We included in the reference section. So
Okay.
what they do is a similar thing on the ACC 10K database. They do a
Mhm.
similar thing and they measure all of the performance of the data. So we take the trained model and we implement our own pipeline of entity extraction. So entity extraction, we use a model that is very standard in named entity recognition, FLAIR model. And based on those entity extractions, that pipeline is entirely set up. Finally, it uses that model, that learned model.
Okay.
Yeah.
And all this code is in your repository?
Yes, it's in our repository.
Okay. I did take a look at the repository a bit, and this leads me to another question. When you talk about extensibility, being open source and extensible,
Hmm.
just nothing really big, but my question is, why? I noticed that you're making use of a lot of module functions. How is this? If you wanted to make this a bit more extensible, what are some things you think you need to do with the code base?
Yeah. So I'll extend on that. So coming to the question answer part itself, I'll extend
Yeah.
how we can do an extension here. So the question answer pipeline currently is entirely automatic. So there is a
Mhm.
chance that the model might generate something very random, something ungrammatical at some place. So how can we put in human in the loop and do a better? So our competitors have this advantage of having human in the loop, so they can gather manual data and put it on the screen also. So we can also put it in the screen, and since it is entirely pipeline, not an end-to-end thing, we can put in the human, let's say, to check the phrase that is being generated, or to maybe check the question that is being generated by the rules, and then maybe tweaking it a bit in order to. So let's say I say, what is the revenue generated? So that is a very correct question. But if I say, when is the revenue generated? So that might not be as canonical as what is the revenue that is generated. So human might come in the loop here and extend this. This way we can extend our entire pipeline. Since it is a pipeline fashion, so this way we can extend our product.
Right. Thanks for that answer. But in terms of let's aside from the financial aspect of things, just in terms of coding, the code itself and the modularity of the code.
Hmm.
Why? My question would be, why the use of general? What I notice is there's a lot of modules and functions as opposed to, say, more object-oriented type of implementation.
Yeah.
Uh, Sir, sorry for interrupting, but then we have a time crunch. We have to take other teams as well.
Okay.
So, so yeah. So it was a good discussion, I guess. So I think we are done with this team. Thank you, team two.
Thank you.
So yeah.
Thank you so much, everyone.
Thank you.
Thank you, sir.
Thank you.
Thank you,
Thanks,
everyone.
everyone. Yeah, Arun, maybe you can give us a little bit of a heads up, like only 2 minutes remaining
Okay.
something.
Sure, sure, sure.
Yeah.
We'll do that from the next time onwards, sir. Yeah, yeah,
Yeah.
sure, sure. Okay, so next team, team, I think it is team six, I guess. Team six. Please raise your hands.
Sorry, how do I leave this call? I don't see a cross button like we usually do. Hello.
You can just directly close the thing.
Okay. Okay.
Yeah.
So yeah, Abhijit. Abhijit, Ayush, Shiva Shankar. Okay, just a minute. Ayush, did you accept the invite? Okay, yeah, yeah, Ayush has accepted. Janet, I am giving access to Janet now. Janet, please accept the invite. Uh, so I guess I have given access to everyone. Uh, can someone confirm it? Is everyone from Team 6 here?
Yeah, everyone is here.
Okay, okay. So you can try presenting. Uh, in that time, I'll just share the modalities. So we have 15 minutes of presentations and 10 minutes of Q&A. So after just a minute, there is a lot of noise from someone's end. Can someone resolve it? Uh, okay. Okay. So let me continue. So after 13 minutes of presentation, immediately after that, a warning bell will be sounded, which will sound like this. So after that, you have to finish everything in the next 2 minutes. So after that, the judges will get around 10 minutes for Q&A session, and then we are good. I mean, the presentation, the entire thing is done. So I'll start the timer. So please start when I ask you to do so. I see that Abhijit Hodda has again raised his hand. Is there any issue? If yes, please clarify now.
Yeah, now it's all right.
Now it's all right. Okay, okay. Yeah. Three, two, one. Team 6, you are good to go now. Go.
Very good evening to everyone. I'm Abhijit from Team 6. Today, I feel honored to present to you Digital Alpha's SEC filing analyzer to all of you present over here. Now, that was a mouthful of words. Let's see what all of these terms mean and let us understand the problem statement. Next slide, please. So, what is SEC? I'm sure you must have been knowing that SEC or Securities and Exchange Commission of USA is just like SEBI for India. It's a lawmaking, sorry, it's a federal agency whose responsibility is to basically govern over the market and ensure fair practices in it. Now, SEC has a database of all the filings called Edgar. Next slide, please. Now, Edgar is basically a database of all the company filings like 10K forms, 10Q forms, and 8K forms, which companies are bound to submit for legal proceedings in SEC. It stands for Electronic Data Gathering, Analysis, and Retrieval, and it's a radical part of governing of the markets from the SEC. Now, what exactly are these filings and what exactly are we going to extract? Let us see in the next slide. So basically, there are three types of reports that we targeted and that the problem statement told us to extract. First is the 10K form. Those are the annual reports which constitute a lot of data and a lot of information, a lot of statistical information, and a lot of redundant information also. It contains business summaries, it contains financial reports, it contains statement of operations, and a lot of other numbers and statistics. Second thing is 8K form, which basically is a list of all events and all the major happenings in the company that are to be submitted to SEC, like let's say a change in ownership, like a change in the board meeting or board committee, and all that stuff. This form is not for submitted in a scheduled basis, and this is an event-driven form. And the 10Q form is a quarterly form of the 10K form. So basically, all the financial reports of the quarter and some trimmed down data is submitted by the company to the SEC in the form of a 10Q form. Now, all these forms are very rich in data, and to extract that, we had to basically target some particular metrics. Let us see some metrics now. Now, the extracted metrics which we uh, aim to extract were total assets of the company, the net loss of the company, which can be a cause of low revenue, strong competition, or increased cost of goods. Total shareholders' equity can be thought of as a total assets minus total liabilities, where total liabilities basically mean negative assets. Uh, Apart from all this, we also aim to extract some other metrics like LTV and CAC, which is respectively lifetime value of a customer and the cost to acquire customers. We found out that if the lifetime value of a customer is more than 3 times the CAC, the company is actually doing pretty good. We also found out about the negative churn rate or the negative net MRR, which is a pretty good indicator for a company. So we also aim to find out that. Now, how exactly did we extract these metrics? I'll hand over it to Shiva.
Yeah, sorry. So what are the things that we have tried here? So the first thing we worked on was working on a sentimental analysis model. So we trained a sentimental analysis model on the financial news clipping dataset that we found on Kaggle. This model was potentially generalizable to 8K forms. It can work really well under manual labeling. Then we found out that there was a file financial report at XLSX file present in 10K company folder. This report consists of lot of valuable information. However, we soon discarded it since we discovered that only 7% of 10Ks submitted in 2022 doesn't have the financial report file. The percentage was much worse for older 10Ks. So the first task involved was fetching the files. SEC maintains a full index of locations of every file. These index files are updated every day. Index files are links to a text file that contains information about a form. We develop an algorithm to parse this index file into pandas data frame. We maintain two parts data index database. One is old index files. These index files are fixed and updated once a quarter. Another is new index files, which are updated every day. So within the text file, we search for the tag file name, which is the file name of the form we are interested in. So let's take an example of Apple Inc. So from the index file, we get the link to the text file. From the link to the text file, we get the extracted file name using the file name tag. We will combine that into the final link to the form. Over to iOS.
So CSV and thank you reports, they were saved using beautiful soup library. So full HTML code for the table was extracted, and the required values were scraped with corresponding keys. So what we did was we actually figured out some similarities between all the HTML documents, and then depending on that we figured out some keys and then scraped them using beautiful soup. So the required matrices were soft-coded, and addition of new metrics can be done easily. And to parse the price, to parse the amount in the HTML documents, we use price parser library. And the prices are not actually just figures. Companies usually give things like amounts are in millions or in thousands, like that. So we also search for those spaces, and depending on that, we came to the result. Next slide. Yeah. So the tech stack we used was React.js and Material UI for front end. but backend was made in Python using Flask. We use PostgreSQL as the database, and for data streaming and preprocessing, we use Beautiful Soup, Pandas, Datetime, and PySpark. Over to Jim.
Okay, I hope I'm audible. Okay, so now we have the required data. So now our next goal is to create a backend to interact with the web page. As mentioned by our team member, like the Flask framework has been used to create the REST API. So based on the requirements and the front-end user interface, these 5 APIs are created. So first is search endpoint, like it queries the list of companies from the database by taking keyword as an input. This database will be updated regularly when the index file is being updated, as mentioned in the previous slide. Also, third-party APIs are used in order to get more information like ticker and company logo of the company for better user experience. And next comes the overview endpoint. This provides the overview matrix of a company by taking CAK as an input. These data are also stored in the database. The detailed functionalities of these endpoints and data storage will be explained in further slides. The rest of these endpoints like metric 10K, metric 10Q, and metrics 8K provides the metric specific to the respective forms. Uh, these endpoints also do the same functionality similar to overview endpoint, but it has a specific responses, specific outputs. Can you move to next slide? So we have used PostgreSQL as a database to store this data. The company table consists of the list of companies. So this table will be updated regularly in every day, as mentioned in the previous slide. Other tables like companies 10K, 10Q, and 8K contains the metrics from the respective forms. The row in this table has been mapped many to one with the company's row, where CAK is the foreign key. These three tables values will be updated on demand request when there is a request to the endpoint. Can you move to next slide? In order to reduce request time and repeated scrapping, we have used a database to store the data. For the endpoints overview endpoint metric 8K, metric 10Q, metrics 8K. When request is received, it checks the data in the database. If data is absent, it scraps the data through the approach mentioned in the previous slide, and it creates a new entry in our database, and then response is been sent back. If data is present and if it's not up to date, it scraps a new data, and then the data will be updated in our database. If data is up to date and it's already present, then it will be directly like response would be directly sent from the data. Like hybrid approach is used to store the data and scrap the data. A column in each row has a report submission timestamp through which we will be able to check if the data is up to date or not. Can you move to next slide? So this is our user interface of our website. So grid component and auto complete component from material is being used to make the search bar. The search bar has a feature wherein it sends the entered value to an API endpoint, which uses the request body to return suggestions for the term that user might be searching for. To limit the load on the server and reduce the number of requests sent by the front end, we have implemented a debouncing feature in the code that only sends a request after 1 second of inactivity of user input. Can you move to next? So this is the company specific dashboard, wherein it displays the company's CAK ID, industry, ticker, and tag. It also shows the company's overview metrics like MRR, CAC, LTV, ARR, along with the percentage of the company's and net MRR. And also it shows the company verdicts. And in other tabs like financials, peers, and events. In events tab, it shows the events from 8K form. And then in financials tab, it shows the metrics specific to financials. Over to Shiva for future improvements. And
Yeah. So how can we further improve our algorithm? So one thing we could do is we can write an algorithm to parse the entire tables instead of do searching for specific keywords. We designing a smart algorithm that can automate what a financial expert would do, and designing an AI system that can recognize important sentences from 10K, 10Q, and 8K forms. We could also make a knowledge architecture that can visually and concisely represent all extracted important information. This way, we can transform data into knowledge and insights. Thank you.
Okay, thanks everyone. Thanks everyone for the presentation. So if we go back to the slides, if you like couple of questions, if you go back to the dashboard, and also I think there was no hosted link for this for your team, right? So we couldn't actually click through and see. Do you think you will be able to quickly show us the hosted application?
Sir,
Yeah. So
yes,
just
sir.
just a second. We have 12 minutes for the Q&A now. So please go ahead. Starting now.
Yeah,
Yes, sir.
can you run through
Abhijit here.
quickly?
To answer your question, yes, we couldn't host the application, and right now there are a couple of missing features that the application lacks. So I'm afraid we won't be able to do that now.
Okay, okay, that's fine. If you go back to the dashboard, maybe you can talk through some of the metrics that we saw. Like, just wondering what is the process or the methodology that you use to extract those metrics? Like, for example, here we see MRR, CAC, right? Can you talk about like what you used, how you used some of the models to extract those, and what are the challenges that you ran into, and what kind of confidence and accuracy with what kind of confidence and accuracy you were able to extract these numbers, and if you have any benchmarks.
Sure, sure, sir. So a couple of metrics like MRR and ARR were actually like we got it in the 10K forms and 10Q forms directly. MRR was a bit tough, and coming to CSE and LTV, a couple of companies actually showed the customer acquisition data, and a couple of them did not. So for the companies we showed them, that was actually easier. Like almost all of the companies showed the statement of operations for the sales and marketing costs, but a lot of companies did not show the customer acquisition information, which are actually important to calculate CSC and LTV. So the customer churn and the net MRR churn was basically dependent on that too. So those were also dependent on whether the company had the customer acquisition data in the 10K and 10Q forms, and about how we actually extracted the data from the forms itself. I'll let Siva answer that.
Yeah. So we manually search for like we maintain a dictionary that consists of keywords that we have to search for, like for example net income or net assets or something like that. So we search through all the tables for match for the keyword, and we extract the values corresponding to that row in the table.
Yeah, but it may not, these things may not appear in the table, right? They may be in the textual form as well.
Yeah, possible. So that's why we are focusing on the values that are present in the table for right now. And as for the test, we are just making a sentimental model. till now.
Okay, so there is the from text we are only looking at from sentiment point of view. We are not extracting the values.
Yes,
Right.
because uh, there are many problems. Like there were repetitive statements that were very confusing, and it's too complicated to a model. And also, if a model makes a mistake, it is too expensive. If we are using some NLP model to extract data from text, then it may make mistakes, and those mistakes, from finance point of view, may be very expensive.
Okay. Okay. I'll let other judges answer ask the questions.
Just really quickly, how code complete would you say the submission that you have in GitHub is? My observation is that I recognize that this is probably work in progress, but many of the things that we're talking about here, MMR, ARR, those types of things, even the sentiment analysis, I'm not really seeing where you're extracting this information or calculating this information in your code base. I do understand that from what you said that it looks that you're right now you're parsing and extracting, mostly rather than deriving. Would that be fair?
Actually, we did train a sentimental model based on the financial data set present in Kaggle. However, that didn't work quite well on the 8K forms. The problem is that the 8K, the language between the financial, the 8K forms and the data we use were a little bit different. So we could have further fine-tuned our model for a sentimental analysis. However, that would take a lot of time and lot of manpower. So we passed it for just for now.
Okay, and so that's why that's not in GitHub. What
Yeah.
I'm seeing, okay. So is it fair to say that right now in the current state, what you have in GitHub is basically the scraper, the extractor, and then you're inserting them into the 8K, 10K tables?
Janet, you can answer that.
Sorry,
That's
second.
all right. The question I said is, I did you did submit with your part of your submission is your GitHub repository, and we do take a quick look at the repository to see if some of the things mentioned in the report we can correlate, we can validate against the GitHub repository. And I'm not seeing things, some of the things mentioned in your report. So I wanted to know what the state of the GitHub repository is. Is it currently basically the extractor code, the scraper code?
Yes,
Yeah,
it contains code which it contains the code which we need to scrap the data, the required data.
Right. Okay.
yeah. Like for example, I don't like there is no sentiment model in that GitHub, right?
No, sir, it's not there because we couldn't able to get the sentiment analysis from the Kaggle database.
Yeah, so as I said before, we could have made that. We could have further fine-tuned our model to perform better. However, that would involve a lot of manual labor. Like we have to manually label data for that. So we didn't have that kind of manpower. So we passed it for later.
Okay.
Okay. I don't have any questions.
Nothing further from me as well.
Okay. Thank you, team. Thank you, team, for your presentation. You can stop presenting, and the next team, I think, is team. Let me check. I think it's team. Yeah, it is team 16. So, team 16, you can raise your hand. We'll give you presenter rights. For that. Team 16. Yeah. Pratik, I have invited you to stage. Pratik, are your other teammates here? Hello. Team 16, please raise your hands again. Uh, yeah, Pratik, you have been given speaker right, so I can't see anyone else raising their hand. Okay, Mukul has raised his hand.
Hello.
Two other members have also raised their hands. Aryaman
Yeah,
Thakur.
yeah, yeah, yeah. Yeah, yeah, just saw that. Ariman Thakur have given the rights. And Pratik, can you clarify? I can't see Ariman's name in the form that you have filled. So,
Actually, no, actually, what happened that we are having a mid-semester exams going on, and so one
okay,
of our team
okay,
member had to leave, and so Aryaman is substitute for him.
okay, fine. So, who else is there? Can you just name the other person? I'll
Okay,
give.
so me, myself, Pratik, another teammate is Mukul, and Saksham and Aryaman, we four will be, and Shreyansh will also be joining. Shreyansh,
Okay.
I will ping Shreyansh.
So please have it fast.
Yes, yes. Sorry for the delay.
So we'll start in 2 minutes, whatever be the case. So after 13 minutes, there will be a buzzer which will sound something like this.
Yes, I got it. Thanks.
Okay. So
Yes.
you have to end your presentations in the next 2 minutes. And the Q&A session will be of 10 minutes, where the judges will be able to interact with you. After 8 minutes, I'll mention that only 2 minutes are left. So within that time, we'll wrap it up, and the entire presentation will be done. So now you can share your screen, and we'll start off at 5:10.
Yes. Uh, Hello, please, can you see my screen now? Can you please confirm you can see my
Yeah,
screen?
yeah. Not yet. Not yet. Can't see you.
I have shared my screen.
Uh, yeah, I think it is visible. Yeah,
Okay.
but
So, I think we will start without waiting for finish. There are some connection issues from our side. So we will
yeah,
start with share.
I'll mention when to start. I'll mention when to start. Please start then.
Yes. So I think can I start now?
Please wait. I'll mention when to start. We said that we'll start at 5:10. We'll start at 5:10.
Okay.
I'll tell you. Yeah, you can start now.
So
Hello, Arun.
Yeah, yeah.
Yeah, I
Just a
think the
minute.
screen is not visible.
Oh, yeah, it was visible for me just a while ago. Now it is not visible. It is entirely dark. Your time has stopped. I mean, there's no issue. Please try to clarify this as soon as possible.
yes, yes, sure. Sir. Mhm.
It is not visible yet.
Yes, I am trying to resolve the issue. Is it visible now?
Yeah, yeah, it's visible.
Just let me make it full screen. Okay. So Piyush, is it visible now or it is gone dark again? Hello, Piyush.
If you are having an issue, someone else can present, if that is
Okay.
the case.
I will just check with my team members and see if they can present on their from their side. Just can you give me a minute?
I think
Uh,
the presentation is visible. You can start right
okay,
now.
if it is visible, then okay. I mean, it is not visible on my
Okay.
end.
Okay.
So
I think
okay,
I
fine.
will
Then
just.
we are good to go.
Okay.
Yeah. I
So
think if it is visible, then we are good to go. I'll say we
Judges,
can
it's
start in.
visible for you, right? Rajesh, Mahendra, Piyush, Sumit.
Yeah, we can see it. I think it needs to be in full screen mode or something, right? It's
Yeah,
kind
full
of.
After
presentation
sharing
mode.
in full screen is going black.
I see. Okay, can you move it little bit to the left so that we can see the full slide? Right now, it is
Yes,
cut
sure.
off on the right side.
So can you see it now? Yeah. It is full screen, sir. Is it visible now clearly, sir?
No, it we
No.
still see the just
Same
go to the
event.
next slide. Let's see what happens. Go to next.
Pratik, can someone else can present from your
I
team?
will try. Can you give presenter access to Mukul Kadian? Mukul from my team.
Okay, just a minute. He's already a speaker. He has already talked.
Yes, so I'll be presenting my screen. So is it visible now?
Yes,
Yeah,
it's
we can
visible.
see it.
Okay. If it is visible, then we can go ahead. Uh, we can start in three, two, one, go.
Sorry, Mukul, I can't see your screen now.
Your time has already started. Please
Screen
sort
is
it
visible,
accordingly.
right?
We can see
Uh,
it, Mukul. Go ahead.
yeah. So hello everyone.
This is just to inform you. Your time is running. Please go
Sorry,
ahead.
please, but actually I can't see the presentation on my screen. Really sorry.
Yeah, maybe you can open it on your local desktop, Pratik, and then you can walk us, we can see through Mukul's
Sure,
presentation.
sure, sure. So hello
Maybe you
everyone.
can.
Myself. I'm starting now. Hello everyone. Myself Pratik, and I myself with Team 16 will be presenting our presentation on the digital alpha SSC filling analyzer for SaaS companies. Next slide, please. So on the next slide, you can see the details about the Edgar Dataset. So what is the Edgar Dataset? It is the electronic data gathering, analysis, and retrieval system, which is a system provided by the SEC of United States of America to analyze where all the companies can upload their financial statements and their financial performance in a given time, and then there the data set is available publicly, so all the investors and students can learn from the data set. Uh, on the next slide.
Uh, am I audible, sir?
No.
Yeah, we can hear you.
Yeah, so next slide, please. Yeah, so as you can see in the figure, we scraped the data from SEC filing, and from there we obtained the financial statements and other financial data. It was a difficult task because proper documentation was not available anywhere, but after some trial error, we were able to decode the process and we were able to scrape everything from scratch. So we use three XML files to scrape the data. For financial statements, the tables were extracted from calculations.xml, and the set of all other attributes were extracted from labels.xml. The values of these attributes were present in extracted XBRL file, and we scraped those from there and combined everything later. So in the figure, as you can see, calculation links were basically the financial statements, and we use the locators present under these to search for tags in the extracted file and use the context references available in the extracted file to determine the period, and then everything was saved systematically in a JSON file and added to database later. So, and we used a similar approach for extracting other attributes from labels.xml. So the scraping module that we have created is very robust, and in future we will surely publish it as an open source library. Next slide, please. So in the data cleaning preparation phase, we cleaned the attributes obtained from the previous step and converted them into a schema defined by us. And for cleaning the 8K forms, which basically contains the announcements, we used regex and NLP based approach and extracted the appropriate data. That is it for scraping and cleaning.
Yeah, am I audible?
There is a lot of echo, just to inform.
Yeah. Yeah. Okay. So I'll be starting now. So can we head on to the next slide? Yeah. So basically, in machine learning, the machine learning module consists of two modules. The first one being the fraud detection, and the second one being the sentiment analysis. So the fraud detection module outputs the probability that a company has been doing fraud in its financial statement. Now, this is achieved by evaluating the major matrices of the company by using a XGB classifier and outputting a number that estimates the probability of that organization is committing a fraud or not. So the metrics are the metrics that are scraped from the 10K forms, like as earlier told. We currently use 13 metrics to estimate the fraud probability, and our model was trained on the AER dataset. Now, this dataset is hosted and maintained by the USC Marshall School of Business, and this dataset is itself created from the Edgar database. Now, to make our whole code base light and the model scalable and expandable, we hosted it on the Google Cloud so that the prediction can easily be made. And this also make the model updatable, as the model can be retained and hosted by a single script. Also, we tested our fraud prediction models on, like, we experimented with many models, and we got the XGB classifier with SMOT, that is random upsampling and downsampling of data. It gave us a score of 0.68. This is the AOC metric that I'm reporting. Now the second model we used was the sentiment analysis. Now, this was done using the Logren McDonald master dictionary. So this dictionary basically provides a mean of determining like which tokens or like corrections of characters are actual words, and what is their like importance and consistency in word counts. And also within the dictionary, it also flags the words according to its sentiments. So to perform a sentiment analysis on a given form, be it 10K or 8K, so the process was to take up the form, uh, strip the text from the form, and do a word by word sentiment analysis on it. So the final output was a percentage of positive and negative words that are present in a given document, and that can be analyzed out on our dashboard. So can we move on to the next slide? So yeah, here you can see the performance of here you can see the performance of various models on the AER dataset. So we experimented with 4 models. The first one being a neural network. This was a custom neural network written. The second one being a random forest. The third one being a XGB classifier, and the fourth one being the XGB classifier with SMOT. So the best one, as you can see, is the XGB classifier with SMOT. Now, can we move on to the next slide? Yeah. So we never outdate. The thing is, like, the models are present on Google Cloud. The fraud detection modules are present on Google Cloud, and whenever the AER dataset gets updated according to the years. Now currently it's on 2021, so it will soon get updated to 2022. So what we can do is this, we have provided a script in our code. You can just simply run that script, and then your models will be retained, and they will be ready with the new data, so that we never outdate with the current trend. Can we move on to the next slide? Now, here are like the comparison in much detail. So as you can see, like, these are the confusion matrices for the fraud detection models. So the one in the bottom right is the one with the is the one of the XGB boost with SMOT. Now we use SMOT, like this is like random of sampling and downsampling data. We used it because the data set that we got of the AER was highly imbalanced. The number of positive and negative class were too less. So we used SMOT to increase our accuracy, and as you can see, it bumped up the accuracy from 0.62 to 0.68. Yeah, so this is all for the machine learning module parts. The next part will be presented by my colleague. Thank you, everyone.
Hello, judges. We can do the Q&A round now.
Okay, so if the teams are done,
Time
and then
almost.
we can.
So, am I audible?
Yeah, okay. If it's going on,
Okay.
then please. Yeah, you are audible.
So we have made our front-end architecture completely based on Next.js. The reason being is that Next.js is the newest React.js framework that helps in scalability and that implements SSR and ISR. So SSR being is your server-side rendering, which means that in case any page you want you come on, let us say your home page, then you don't need to actually reload the pages, all those routes, right? So you can just render them on the server side and you can just fetch them as static pages, which increases your scalability. As well as we have ISR, we have implemented ISR. So because of that, there are many instances where you have your static page right on your web app, but in case there is some changes on the back end, it also changes on the web app right on the go without any reload. So that's why we have used Next.js site for Next.js tech stack for our front end. Now for the back end, over to you, Shriyansh.
Shreyansh, you can continue. Mukul, you can continue the backend part. Shreyansh is having some issues.
Okay, sure. So actually, Shriyansh is not able to join. So for that, we are continuing with the web part. Okay, so backend we have backend is completely based on the Open API 3.0 specification, and we have developed it using API first approach. So we have used MongoDB database for storing the filling and other data, because MongoDB stores all the unstructured data, and we have seen that all the company's data was so unstructured. For that reason, we have used our NoSQL database, and primarily MongoDB is the best example for NoSQL database, because it also helps in horizontal scaling as well as vertical scaling. That is the prime concern for such web apps. So yeah, and this is our front homepage for the web app. This is hosted live, and we have provided even with the link. Okay. So yeah, now on our web app, we have put our main focus on few matrices. One of them being return on equity, liabilities, financial leverage, operating income, non-operating income, depreciation, income taxes, and net income or the loss. So in case a user comes on any company, he'll be able to see these matrices. Then we also have finances and announcements. So in whenever you come on this page and you click, all these matrices are clickable, and you'll be provided with a beautiful graph plot which will give you the more instance of all these matrices. So these are the finances, and yeah, now announcements you have for the any company. That's it. Yeah. Yeah, this was the matrix graph plot we have. That's it, sir.
Hey, did you look at any of the SaaS metrics like ARR, MRR, how to extract those numbers from the textual filings?
Sir, in most of the filings, the customer data are not available, and we try to extract the most common data metrics and structures which are available to us. And customer data, as you know, might is really confidential for some companies. So we tried to extract all the metrics we could from the XMLs, but we couldn't get any customer data. So we decided to implement all the metrics which are used by general companies.
I think someone has to go on mute, I think. Okay, cool. I'll let Mahindra or Piyush or Sumita ask. I'll come back.
Yeah, so I have one question about the data cleaning So on the data cleaning side, you were talking about 8K form cleaning, and you have used regex and NLP based approach. So I just want to hear more about in technical details, how you have used NLP and regex based approach for that.
Saksham, I think you can answer that.
Yeah, I can answer that. So for the regex was used to like extract common expressions like say dollar sign, say punctuations, and say full stop. So the normal punctuation symbols that are not required while like doing the sentiment analysis and all. So we used sentiment analysis, means regex there to remove the punctuations. Now for the NLP part, first we did was tokenizing. Like given a word, we can like we can use NLP to tokenize it into integers, array of integers. And then what we did, like first of all, and after tokenization, we did it. We went forward lemonization. So what is lemonization? So, say like you are having two words like Apple spent $2,000 on this product, and Apple had an expenditure of $2,000. So these two sentences are nearly the same meaning, right? But they can be like seen as the different sentences by like to the machine. So what lemonization does is like bring similar sentences to the like bring sentences with similar meaning to like to a local like it plots them to a local line, like say to a local vector space kind of something. So what will now the process of NLP was first like tokenization, then lemonization, and then and after lemonization we have we got a common text basis of our script form, whatever it was, and then we can means easily print it on a txt file and give an output. And like this was further passed on to the sentiment analysis models and all.
Okay, thank you.
This is Mahendra. A quick question, maybe two questions. I'm looking at the link you provided to your hosted app. This when I try to search for the companies we had given, most of the companies I'm unable to search for, but I am able to click the four that you have there. Can you explain, is that working, or did you only see data for these four companies?
So actually the point is that we could only find the data, get the data for about 160 130 companies something. So we try to it is not a good thing, but it is only partial data from the 135 companies which you were able to scrape for now.
So only these four companies you were able to scrape?
No, sir, about there were total of 135 companies, sir.
Oh, 135. So
And,
what's another company, if you have, okay, we can get to that another time. I'm not able to search for something like Datadog or Autodesk or Microsoft in your search box. Is that functioning properly?
So I think we would have to add a function called type ahead. Those were on our agenda, but
Okay.
due to the lack of time, we couldn't implement them.
Not a big deal. The second question is you're using Express.js for your server. You're using Python for your analytics for sentiment analysis and fraud detection. Can you talk a little bit about why the decision for those two technologies once more? I know you covered Express.js a little bit, but why not everything in Python, or why not everything in Node.js or something?
So that developing using the Express was easier, and I think Shreyansh and Aryaman can answer this question more better than me.
So
yeah, so
actually,
am I audible?
yeah.
Yeah, we are using Express.js because Node.js is great for IO work. And what we have to do in backend is take the data from the database, just process it a bit, and just send it to the server, or send it to the front end. That's why we chose that. And we use Python because it's great for everything web scraping and ML related.
So the Python is more of a separate process that does the
Yeah.
scraping and then inserts it to the database, and then your Express.js.
Yeah, it's actually hosted on cloud, and we were thinking of building automated services that would just rerun it every few hours, like a cron job or something.
Okay, got it. All right, thank you. That's all the questions I have.
So I have a question about the fraud detection model that you had. Like, in order to detect the fraud, did you have any reference paper that you used, a model that you basically that was pre-built that you used, or you built it from scratch? And what was the thinking? What was the thesis and hypothesis behind that?
Yeah, about the fraud detection, like we got a few papers from the internet. We have mentioned it in our report as an appendix. So the papers talked about using the AER dataset, as I mentioned before. So like this AER dataset is like derived from the Edgar dataset, and it's always monitors if they are AER filing for any company, that means the company has done fraud in the previous year or like in a recent time. So like we use the data from that part only. So actually, we got a we got a pre-built model, but that was in matplotlib. So what I did, I read the whole research paper, and like I got the architecture what they were using. So I replicated the same in a neural model, but again the neural model was not performing as well. So like I shifted it to newer versions like random forest and XGB, and after that again the data set was highly imbalanced. So I again used like sampling so that we can have a better accuracy. So at last I ended up at XGB this mode. So like this was the whole thing about the fraud detection.
Okay. Do we have any stats around that, which is whether
Yeah,
that model is
means,
not the model that you've built, but the paper and then the ongoing findings in terms of how well that particular model that was presented in the model was actually able
yeah.
to.
So yeah. I initially I tried to like replicate the scores. So the paper achieved an AOC of, I guess, means it was 74 point something, 0.74 like AOC. So I couldn't replicate the total AOC, but I got near to 0.68. So this was the means that was the AOC metric that they used. Like they what they achieved, the accuracy, like the AOC score was 0.74 for the research paper, and I ended up around 0.68.
Okay. And of the several papers that you evaluated, why did you pick that one particular paper?
Is because of the matrices that they used. Actually, there were many papers. Many were using 55 matrices. Many were using 60 matrices. But this was because of the papers are older, right? So the I see the Edgar now the way of naming the matrices has changed a bit, I guess. So that's why we are not getting all the 55 or all the 60 same matrices. So that's why I chose a paper which was having the lowest number of matrices. So
Sir, we have around 2 minutes left for Q&A.
Okay. Thank you. Okay. I don't have any other questions. Thank you.
Okay. Thank you, team. You can stop sharing your screen. If the other panelists don't have any other queries, then the team can stop sharing the screen. Uh,
Thank you, everyone.
yeah.
I hope we answered all your queries.
Yeah. Thank you.
Thank you. Yeah. So now we have team 21, who is next. So, yep. This team, please stop sharing the screen. Yeah. We have team 21. So, please raise your hands. Okay. Team 21 has Raghav, Prateek Kumar Singh, Neeraj, Kaushik, and Chinmay. So I'll give rights to each one of them. Raghav, I've given you presenter rights. Uh, I can't see other people raising their hands. So
Am I audible?
yeah, Raghav, you're audible. I can't see your other teammates. Uh,
Yeah.
so you were asked to stay on standby, right? So where are
Yes.
the others? Where are the
Yeah, I
others?
told them they are in the meet.
Okay, okay, okay. Then I'll check if they are in the meet. Then
Um, but yeah, actually,
Kaushik and Chinmay won't be able to join as they are on flight. So,
Okay. Then you three only will be presenting, right?
yeah. So
Okay,
I'll
then
just try
please,
to share my screen. Like,
yeah, please share your screen. Yeah. So for the panelists, this is team 21. Yeah, so while you're presenting, I'll share the modalities with you. So the modalities go this way. So after 13th minute, we will ring a buzzer, which will sound something like this. Okay. So after this buzzer, you are expected to wrap up your presentations in 2 minutes. After that, sorry.
hello.
So after that, there will be a 10-minute Q&A session, and after that, we are done with your presentation. So I'll ask when I'll tell you when to start. I hope all the other things are ready, right, Raghav?
Yeah, yeah. Are you able to see my screen or is it problem?
Yeah. The screen is very much visible.
Okay.
Uh,
Thanks.
okay. So let's start without further ado. Team, you can start in three, two, one, now.
Okay. So good afternoon, everyone. So as a representative of Team 21, I'm going to present our solution for Digital Alpha's SEC analyzer for SaaS companies. And so this is the logo that we chose for our web tool. And so I'll be presenting my solution in this timeline. So I'll just analyze my problem statement. Then I'll give a roadmap to my solution. Then I'll just overview it, and then I'll say there is a mistake in that. I'll then give the data, then ML, and I'll then later tell the drawbacks and the future plans. So what was the problem statement? Let's read it once. So, what we had to do as we had to scrape the SEC's Edgar database for these three forms 10K, 8K, and 10Q forms, and also other, but those were not advised. Then we were asked to extract meaningful SAS metrics and sentiments from the form, key values and tables from the form from for the 10K and 10Q. For 8K, it was mostly related to sentiment, and later we had to collect all our data and then show it in the form of web tool for user. Then we had to show its SAS metrics and how the company is overall performing. Um, so this is what the solution we have proposed. So we had created a script to extract the link and forms for the basic company details. Then we scrape the form for important tables and financial statements. Then we extract the useful data from these forms, and then we store it into the database. Like, we are not doing it on live. We are storing our information and then telling you. And finally, we are creating a web app. Front end will show the user when he queries the ticker name or CIK. So this is the document scraping. First, we find CIK of all the listed companies that were given to you by us, given by you to us, and then we extract all the accession numbers of those documents, and then we create a link to the actual document, and we scrape the essential data, and we then store it in the database. So this is we actually ran a script for all the companies, and we found out whatever the forms they have released for over the years, and then we went to the documents to scrape their information, and then we then store them into the database. So the SEC filing breakdown, that is what do this SEC filing actually contain. So they contain the earnings, the 10K form that contains the earning reports, the assets and liabilities, the risk factors that a company possess, and the company growth and how they can manage their the next quarter and all. So it generally gives the overview of how the company has performed annually. 10Q is what I found it is more similar, is like 10K only, but it gives the information about the first 3 quarters of an year. So then it gives the forward the same. And then the 8K form, which is released when there is any sort of event or when a company has any lawsuits, and this is all generally accompanied by a press release. So we had created a backend, and I'll just tell you, like, we first wanted to create this using a Mon stack, but we used Django as it is Python, and we realized that we had to use ML, and for scraping it is really good. So we built our API on Django. So we have currently 5 endpoints available. We don't have any post and patch or other requests can, as we just ran a script that we have shared with you in a solution and the scripts folder. We ran a script, and then we uh, placed all our data inside that. And this is our backend API hosted. And so these are basic 5 APIs. So we use them and to query our database and then into our front end. So, like, for all the companies, we have given the basic info, that is the market cap and net income, sales, and their stock style. Also, the various positions the people in the company have had, and a brief summary of how the company is, like how the company earns and what the company actually does. This is a database model design. We used MongoDB, NoSQL. So because the data has to be a lot flexible, that is why I used MongoDB. Mostly Django has to go with Postgre, but still, so we used PyMongo for this, and we actually this is for the 10K form. So for a 10K form, we store a CIK, then a ticker value, then a form, accession number, and in the data, and then we store all the data that we collected from the tables. And these are around 3.7 documents to process. So I think we missed a lot of other companies as well, but we were successful in other forms like stocks and basic company details. This is a user. So this was built on React. Sorry, it was library, JavaScript library, React. And for the user interface, what we did, like, a user had to, if a user is unaware of about any company, he can just type the first letter of any ticker he knows, or he can just type the company name, and then he gets this cards, and through these cards then he can like click and view the information. We have also made it mobile friendly, so this is how it looks. So, and this is these are the cards, like, for if we put any company ticker as a query. We can also input CIK as a query or title of the company. And then this data includes the charts that we used using Google API, Google Charts API, and financial metrics like common stock prices, cash flows, and annual revenues, etc. So what a company's data comprise of? So it comprises in this way: the CIK, the ticker, the title, the summary, and then it will ask you if you want to see extra details about a company. Then it gives this information: the net income, sales, sector, industry. This we all scraped from scc.report, and this is the stock graph. It actually is divided as the average stock it had for about a month. So all this will be for all the 12 months. And also we made a model for predicting our next stock prices also. So that is included in our scripts report. Now the ML model and performance, like, I will ask my friend to explain this one.
Hello everyone, I'm Miraj Shah, and I will be the one who will explain the machine learning models and everything it does. So, firstly, the reason that we decided stocks as our basic input was that the MRR and CRR and other SaaS metrics, they were hidden in the textual formats of the company SEC filings. but there was no predefined structure to that. Like if we were to generalize even to a maximum possible extent, we wouldn't be able to extract data for more than like 50% of the companies. At least we didn't know how to. So that's why first of all we focused on the tabular data, and then we found stock prices of majority of the companies that were listed in the question. And so we made a LSTM model, and what that model basically does is it is a kind of regression. But as we all know that ac- predicting a stock price is not actually very accurate, because if it was, many of us would be millionaires by now. So what it basically tells you is that if you should invest in a particular stock or not, it tells you the trends of the future 12 months. Uh, it will adopt, but take it with a grain of salt. And along with that, we also did another model. If you can, next slide please, Rahul. Yeah, this is the sentiment analysis. We used a pre-trained model of Finbert for this. The model Finbert is actually an NLP model implemented for financial data, along with all the necessary wordings and all that is mainly used in financial filings. So what we did was, we first of all extracted sentences, and any sentence that were more than 200 characters, we filtered them. Then we similar like any other NLP model, tokenized and all. And then the Finbert gave us three confidence levels. There were neutral, positive, and negative. We like disregarded all the neutral ones and the positive and negatives. So the positives and negatives were the ones we used. We took average of the whole SEC filing on that positive and negative model on each sentence, and by taking an average, we came out as the overall positive or negative rating for a company's textual database. So that was all for our sentiment analysis. And the next,
Okay,
yeah.
so for our for our for our solution, the drawbacks. So we weren't able to find any regular SaaS metrics like ARPU, ARR, MRR, or customer churn rate, lifetime value, as we didn't know how to extract all the customer data. So, and also the ML models that we talked about are not available in a web tool. They can run on the local server if you wish to, using the GitHub repo or the zip file we sent you. But it didn't work on the production, so we failed in that part. Also, for our future plans, like we wish to implement that comparison one and all the SaaS metrics. We also want to give the overall the data that overall result of how the company is performing. And also, like we want to make this as an automatic thing rather than scraping all the information and storing it into the database. Rather than whenever a new file comes, we can the script can run and it can put that in our database, and also like delete some of the past one if it's not used. So thank you. This was all for the presentation.
Okay. Thank you. So we'll have a 10-minute Q&A session. I'll start the timer so we can start now. So Rajesh sir and others, please.
Okay, maybe I'll start. Thanks for the presentation. A couple of questions. You did mention that ML and the Finbert stuff didn't make it. Is that why I don't see any code related to that in the GitHub repository?
We actually included the code. It is in the scripts folder in the GitHub repo.
Okay. You mentioned that it's not available in a web tool because it didn't work. Can you elaborate on that? What do you mean by it didn't
Actually,
work?
it didn't work in the production. Like when we wanted to deploy our server, so it didn't work in the production. Like we are hosting it, so we couldn't host it, but it worked on our local server. Like
We
Okay,
didn't know how to
okay.
deploy it.
Okay, I got it, got it. Because
we
I
failed at
noticed
deployment.
it's a Python notebook, right? That you have in there. All right.
Yeah.
Um, the other question, so this is, I think it's good that you did do the machine learning and at least you got it working locally. Were there any other insights you got gathered from um, scraping or mining the data, the SEC data that you thought about?
We gave this data that from the SEC filings, right? Yeah, the SEC filings, these are not extracted from the SEC filings. From the SEC filings, we were able to use this charts. Those were like stockholder and I mean all the table from the balance sheets and all, like the annual whatever the sales they have done. So like when you open our web tool, you can like use this charts to see how the company has performed. I showed this one, like the total assets, total liabilities, net loss per share, this one. So we had created charts for all these ones.
Uh, okay, these are basically, are they? They're basically a time series of the data you scrape, right? Historical.
Yes.
Okay, I'm having problems actually using the search function on your link, the link that you provided. Is that functioning?
Yeah, the search function should have worked. Maybe it's a bit slow, I think.
Yes, sir. Even I tried it multiple times. If you press enter more than once or twice, it doesn't show. I know that's a problem there.
I
Okay, all
think
right.
we failed at mostly at deployment, so I think you can look at our GitHub repo.
Okay, that's it for me.
Okay, thank you.
Okay. This is Rajesh here. So did you use any models that are out there, any open source APIs for SEC scraping that are out there instead of building things?
We didn't use any API. We everything actually we I scraped it from sec.report. That is a website. So they gave away some of the basic info. So I did that, but we didn't use any external APIs. I think we used for Yahoo Finance. I think for the stock. Is it? Raj?
For stocks, actually, the case was I used Pandas data reader, but from one API there were a lot of not number value in between. So I used multiple APIs like Yahoo and Quandle and all, and just congregated all of them and took the monthly average. But
Okay.
the main library was Pandas data reader.
And for the SAS metrics which you couldn't find and extract, can you like talk about the effort that you put in? What are the different things that you tried? What are your observations in terms of um,
Yeah, actually, we tried to find the customer data, like whatever the SaaS metrics are given, like ARR, MRR, or the customer value. We actually need how many customers there are. They are changing per quarter or around like that. So like we tried to read all the 10K filings and 8K filings or 10Q, and we couldn't find inside them. We don't know like if there were any other sources as well, but from the filings perspective, I don't think we were successful in that also.
okay, but let's say, for example, even if we disregard the SAS specific metrics that we gave, any numbers, if you have to extract from the textual sections of the filings, like, did you try anything that can
Like we
basically?
tried using
Yes.
NLP, like we tried to extract the key value pairs. Like if Miraj can
Yeah,
explain this one.
actually, we did try that, but the problem was that first of all, not every textual data is actually in a digit form. Like some of them are in wordings. Some number data is in wording form, and along with that, not all companies actually disclose that customer data and all. So if we take those two things in consideration, we were only able to like extract data for less than 100 companies. So that is why that wasn't very consistent, so we actually stopped that. And Raghav, I would like to say that if you can share your screen and show that website and search and all, because we front end might be a problem, so we know how to do that.
Okay, but like
Um,
when you actually compare with the problem statement with what you have done, like how much percentage do you think? What are the key things that you would say you have achieved here?
Yes, sir. According to the problem statement, we did show all the tabular data that was available in 10K, 10Q, and from the 8K, we show the sentiment analysis, and along with that, the SaaS metrics. I think really professional levels of investors are actually the ones using them. But if um, we are in somewhat beginner to intermediate level, if we want to get the basic idea of investing, we also show it with our stock price predictor and sentiment analysis. So for that investing part, I think our project will do the thing, but for exactly the SaaS metrics part, I think we are lacking.
Okay, okay. I don't have any other question.
Okay, so if no other panelists have any other queries, then we are going to.
like we wanted to like show our
Okay, so yeah, you can do that. You have 2 minutes left in the query session.
so like these are the
Sir,
cards that are so like if I go into so like some of the charts are not available like as we couldn't so that's somewhat the problem like we couldn't extract all the information.
Okay, yeah.
Okay then thank you for the
thank you,
present
sir.
giving me the opportunity.
Okay, yeah, thank you, team. Thank you. So next we have team one. So team one, if you are here, please raise your hands. Okay. I have handed mic to
Hello.
all three of you. Yeah. Uh, yeah. So please try if you are able to, present your
Yeah, I'll
screen.
just share my screen. I'll just do that.
Yeah. Yeah. Yeah.
Share screen. Okay, so is the PPT visible?
Yeah, it is visible. So before you start off, I'll give
Yeah,
a brief overview of how we will proceed today. So
definitely.
of the 15-minute presentation, after the 13th minute, you will get a beep like this.
Okay.
So I'll have this sounded, and you'll have to wrap up your presentation within the next 2 minutes. After that, you'll have to. I mean, after that, obviously, the company representative, that is Rajesh uh, and others, will definitely ask you some queries. Then that would take around 10 minutes, and then your presentation is done.
Got
So
it.
got it, right? So okay, I'll tell when to start. Then you can go.
Definitely.
Okay. Yeah, yeah. Okay. Okay. Three, two, one, go.
I welcome you all to our presentation for Digital Alpha's SEC filing analyzer for SaaS companies. Looking at the problem statement, the first thing we did was decide the architecture and the tech stack that our team was going to use to get the proposed solution. According to the problem statement, we found out that the tech stack best to be used was as follows. For the front end, we are using Angular framework. For the back end, we have created a REST API using the Django framework. Our database is an SQL database, and the charts library we have used is the ng2 charts in the front end. The source code can be found here, and the hosted solutions are also found here. We'll be coming back to the hosted solution after the PPT. Uh, Moving on, our solution can mainly be divided into three main components: the backend, the front end, and the scraping and the ML model that we used. This is the basic architecture of our of our solution. What we are doing is we are scraping the data from the Edgar API. Once we have scraped the data, we are converting it into CSV files. After converting it into the CSV files, we are traversing through these CSV files and feeding the relevant data from these CSV files for each company into our SQL database. Once the database has been seeded, we then run the ML model on the updated database. After running the ML model on the updated database, we get certain parameters such as growth, profitability, and investability of that company, which we then again feed into the database. So basically, our database contains two types of data. One is the metrics that we directly scrape from the Edgar database. The second is the metrics that we generate using our ML model. Once we have gotten the seeded database, we can then use our backend Django REST API to query data from the database and present it to the front end as and when required. Moving on, this is just to go a little deep into the backend. The backend not only queries the data, it also powers the authentication, the search functionalities, and the favorites functionalities. It also has the compare functionality. Uh, the front end is written using the Angular framework and provides a fluid dashboard for easy viewing and comparison of SaaS metrics. Uh, Moving on, also uh, ju- uh, the entire process of scraping the data, converting it into into CSV files and seeding it into the database is scheduled using cron jobs, and it runs once a quarter. You can specify the duration of the cron jobs as per the requirements. Our database tables look something like this. First, we have the user profile table, which contains the basic user data. Moving on, we have the company table, which just contains the name, the CIK number, and the ticket number of the company, as well as the count. The count here signifies the number of hits that the company gets. This way, we can also show the most searched companies to each user, which basically tells us about which companies are being searched more, and this also gives us sort of insights, right? Third table is the metrics table. This table is linked to the company table with one-to-many relationship and contains all the metrics for a particular company which are scraped directly from the Edgar database. The fourth table is the performance table. This table contains the data which we generated using the ML model. And this is linked to the company model using one-to-many linking. We also have a company favorites table, which basically is linked to the company table as well as the user profile table. And if you add particular company to favorites, an addition is done to this particular table. And the token table is there for authentication. So I'll just move this by side, right? Um, Moving on, the front end is built using Angular along with ng2 charts library for showing graphs. The front end is easy to use and provides an intuitive UI to the users. It has the following functionalities. It has metrics of a particular company. Side-by-side comparison of metrics of up to two companies is available. User can search companies by name and can add them into their favorites tab. This is just reiterating the design philosophy. So some of the functionalities that we have provided detailed charts in our front-end dashboard. We have also provided the functionality, like if you click on a particular metric, you go straight away to the online CSV file from which the data was scraped. And you have the traditional sign-in and register pages there as well. Moving on, for the scraping part, we moving on to the scraping, we used Beautiful Soup with Edgar API, paired with the Edgar API to scrape the data. On scraping the data, it was converted into CSV files. The reason for converting it into the CSV files was that if in the future, if a user ever wants to cross-check the information on the dashboard, they can do so directly through the CSV files rather than going through the Edgar database and finding a particular value out of the larger amount of data present there. Now we are scraping the following data. We are scraping the annual revenue, quarterly revenues, liabilities both annual and quarterly, profits between the line both annual and quarterly, profits annual and quarterly, net income annual and quarterly. Moving on to the ML model, Nile will be taking over from here.
Thanks,
Nile, if
Parwan.
you're there.
Right. So after collecting the data from SEC archives, the first issue that we faced was labeling the companies on the basis of growth, profitability, and investability. After a quick look up on the web, we found various formulae for predicting these quantities. Because of these various formulae, we got confused, and therefore we decide, and also that we were lacking the required experience and knowledge to assign values to these quantities. Therefore, we decided to approach Dr. Bhaskar Jyoti Nyog, our economics professor, for helping us out on this issue. He being an expert in the field, we asked him to label the dataset for us. After the job of preparation of data was complete, we initially thought of using decision trees as our model, but then we quickly realized that the availability of data was less, and therefore the trees are bound to overfit the data. Therefore, we dropped the idea of using this decision trees. After dropping the idea of deploying decision trees, we finally opted for four regression models, which were lasso regression, ridge regression, support vector regression, and naive Bayes. Since the amount of labeled data that we had was less, therefore, during the initial phase of trying out our models, all of them overfit the data. Then we decided to use smart oversampling techniques for augmenting the data that we had at hand. And using this, we were able to convert 8 data points to 100 data points. After this, we tried training our models again. And this time we found out that among these four models, naive Bayes gave the most accurate results. And hence we decided to go with the naive Bayes model. Now Parwan will be taking over from here. Over to you, Parwan.
Thank you, Nile. Moving on to the key problems we faced. So the first key problem that we faced while scraping the data was that the parameters were not uniform. So for particular companies, the total yearly revenue was mentioned as closed consolidated revenue. For other companies, it was just consolidated revenue. For others, it was just total yearly revenue. So in order to solve this problem, we imported pre-trained models of the BERT transformer, which we then used for generating the word embeddings. We then used cosine similarity for finding out the similarity in these particular tags with a threshold of 0.075. So what this helped us do was pair the particular metrics of a particular type into the database. So for example, the revenue for companies were fed into the database under the revenue type. And this reduced the flexibility of the database. Hence, we were able to use the SQL database. This would help us later if we want to run better ML models and process the data. If we have a metric type associated with each metric. Also, we, as Nile just mentioned, while labeling the data for training the ML model, we were unsure as to how to label the data, and we would definitely like to improve that process in the future. Our vision is to expand our particular front end and back end to encompass not only SaaS companies but also all companies that are provided in the SEC database. We also plan to improve the ML model both through its training data, labeling it better, as well as finding better ML models itself. We also plan to extend the functionalities of our front end as well as the back end, such as provide share price directly on a dashboard and other metrics. Thanks. And I would just like to show you the live demo right now. This is the login page. So I'll just log in. You can also register. So say if you're a new user, you can just register here with your username, email, and password. But since I already have an account, I'll just log in. I think just a second. Yeah. So here you can see the dashboard that the user will be seeing. You can search for companies here. So say I search for Microsoft. Microsoft shows up. You click on Microsoft. The first thing you see is the star here. So I'll just come back here. You see the growth, profitability, and the investability. So these are the metrics that we generated using the ML model. Moving down, these are certain graphs. Now these graphs have been generated from the metrics that were directly scraped from the SEC. So if I click on a particular value, say this value which was for 2019, uh, it takes me to the XML file from where the data was extracted, right? Moving back to our dashboard, we can compare companies. So, and we can add them to favorites as well. So if I add this company to my favorites list and I go to the favorites list, you can see Microsoft has been added here, right? Now, going to Microsoft again, if I remove this, it'll go away from the favorites tab. Now, if I want to compare Tyler Technologies against Microsoft, I can do that. And as you can see, you have a side-by-side comparison of the metrics of the two companies, right? Moving back to the home page, I would also like to point out that we have a tab for most viewed companies. So these are not most viewed for a particular user, but across the entire front end. So basically, if all the users are searching for Microsoft, there must be some kind of interest in that company, which also gives insights to the user. Moving on to the users tab, you have his email, username, and we can extend this to other details as well in the future. And you just sign out, and this is about it. So, and we are open to questions. Thank you.
Hi. Good presentation. Question. Could you expand a little bit on on your landing page, growth, profitability, and investability? How do you,
Yes.
yeah, how do you come up with those?
Okay. I think Nilay would like to take that question because he worked on the ML model. Nilay, should I go ahead with the answer, or would you like to take the
I think
question?
Pravan, you can take this question.
Okay. So, sir, for now, what we have done is we got the data labeled from our professor. So, say we gave him data for 10 companies. We asked him to label for growth and profitability, right? And after that, using this, we ran this ML model. After training it, we ran it on other companies. For now, our database contains only about 10 companies here. We were unable to scrape the data for all the 300 companies due to lack of due to time constraints. Um, and so this is how we come up with the growth and profitability. As far as investability is concerned, we just add growth and profitability and take an average of that. So this is, I mean, this might be.
But are you running the ML on the raw
Mm,
text or on against data? Okay, so you have three
no, no.
steps where you scrape the data and then
Yeah.
you post process the data.
Yes.
After you run the ML and then you reinsert that data.
No,
Is
no.
it a
That the
structured data or unstructured data that you're running the ML algorithm on?
Nilay, would you like to take that question?
Actually, I would like to answer that. So, when we scrape the data from the Edgar filings, we actually scrape the main tables that included all the financial terms. What are the total assets, the total profits, how they are spending on acquiring the customers. So we gave this data through, as Pravan and Nile said, that we gave this data to a professor. So they just gave us a random idea and labeled few of these data sets. Then we use that as a reference to calculate the profitability and growth for all of these companies.
So
Okay.
basically, we were unable to, like, we wanted to find a better method for labeling the data,
Mm-hmm.
but due to the time constraints, we are unable to do so. But I can show you the, I think, can we just show the admin panel for the Django
Okay.
backend?
You don't have to. We have limited time, so
All right, all
let
right.
me just ask another question and give the
Yeah.
other members time. The ML code, is that in your repository? I was
No,
looking
sir.
through it and I don't
No.
see it.
No, the scraping code can be found there, but the ML code we did not include in the GitHub repository right now because
Oh,
we ran that after submitting the code submission.
I see. Okay. That's it for me.
So on the database side, it is MySQL or MS SQL.
No, just SQL.
Okay, so
SQLite.
okay, so why not the NoSQL database?
S-
Like, what is the motive behind using SQLite?
so basically, we wanted to have these relations between the various tables. So we wanted to have many-to-one relation between the company and the metrics tables, and for that we needed an SQLite database, SQL database.
Okay.
Okay, where you guys talked about the problem of different metrics showing up with different names, where you use
Yes,
the cosine similarity with the threshold. Can
yes,
you
sir.
talk a little bit about and you organize them as a revenue type, um,
Pardon?
like
What is the last part of the question?
where you organize them as a revenue type, right? So let's say, for example, someone says consolidated revenue versus revenue. You're basically
Yeah,
fine. You're basically bucketing them as, oh, they mean this. They mean the same thing. I'm gonna use them for my calculations,
ex- yes,
right?
yes.
So what?
Yeah.
Um, like if like, did you also look at the XBRL format? Maybe in that format, you don't have to worry about the change in the labels because you have the access to the underlying elements.
No, no, we did not look at that. We just looked at the scrape data, and that was it. And we went from there. Went ahead
And
from there.
so for the cosine similarity part, what we did was we used a pre-trained BERT transformer model for generating the word embeddings. And then because each of the filings had different names for the columns which were filed, so for extracting all of them, we used those embeddings. And by finding the cosine similarity, we extracted those things from the SEC archives.
So what was the input to the BERT model? Like, was it like the text form of a particular filing,
Right.
or
So the name of the column of the table. The table contained the information about the company's uh, uh, recent activities, and based on those headings, since those headings were different for each companies, we gave the text input to the BERT model. Then we got the embeddings and then compared the embeddings and the similar embeddings. On the basis of that comparison, we extracted the information from the SEC archives.
I see. Okay, got it. So it's the table headings, not the actual metric names.
Right.
Okay. But did you notice that the metric names also could be different? And how do you basically come up with, let's say, if you have to basically say, hey, these two metrics, they come with different names, but they actually mean the same thing.
So that's what we use the BERT model for. I mean, even if the names are different, uh, but somewhere it could capture, the BERT model could capture the similarity, right? The names won't be completely different. I mean,
But sir,
Right. Okay.
even if they are completely different, we have not accounted for that right now. Uh, but we would be.
Yeah, yes, yes. Actually, we use some of the names as a reference. So, if a consolidated balance sheets, so if a company is using some other name or just using balance sheets, or for other of the matrix also, we use only few of them. We collected a few of them as references, and then we gave our input and calculate the cosine similarity with the reference to the previously collected numbers.
Okay. And did you run this against all like the full universe of 130, 135 companies?
No, sir. We ran it against 10 to 12 companies.
Okay.
But
Okay.
sir, our model, even our scraping script is all scalable, and we do have confidence that it will be able to run on all the 130 companies.
Right. And also the labeling that Professor helped you with. Can you give us a little bit more idea in terms of what that data looked like and what did he actually label?
Sure, sir. I just if so the data that we
So we have
provided him
exactly
with.
2 minutes remaining for the Q&A session. Please continue.
Um, where's the data? Okay, wait. Go into it. Scrape CSV files. So, 10.
So in the meantime, I could explain that what the professor did was he basically looked at the filings and the data that we scraped, and on the basis of that, he decided to provide numbers to the profitability, growth, and investability metrics.
Okay.
Yeah, so we provided him with CSV files for certain companies. So this is a CSV file for a particular company. So this is a particular company, and it has that we generate, and we provided him with like tens of like around 10, 15. There were around 10, 15 CSV files for each company. He looked at those and then just gave us the numbers. So we'll have to talk to him regarding the exact process that he used.
Yeah, he gave the numbers for the
for labeling it.
He gave the numbers for the growth profitability of those
Growth and investability.
Investability for
Yeah.
these 10 companies by like some methodology he might have used.
So I think he
Yes.
basically used his experience.
Okay, so he basically came up
That
with
can't
like,
be.
okay, got it. Okay, cool.
These are the 10K and 10Q files that we generate. So it also has a format. So with a CIK number underscore the type of a file and the date on which it was filed, and we have these files for a large number of companies.
Okay,
Almost.
cool. So thank you.
Thank you.
Yeah, the time is done.
Thank you everyone for
So
the
thank you,
opportunity.
team.
Thank you, sir.
Yeah, thank you, team. Thank you, team. Okay, so this was team 1, right? So now we have team 11. I hope team 11 representatives are here. So if they are here, please raise. Okay, we'll give you the access shortly. Just a minute. So Kaushik, Pranav, Gitanjit, and Aryan. So I hope only these 4 people are there. A fifth person also had filled the form. Uh, okay,
Yes,
okay,
yes,
all the
he'll
5
send
are
a
here.
request in a moment. Okay.
All the 5 are here, I guess. So. Uh, so teams, you can try presenting. In the meantime, I'll try to give you a brief of how the process will go. Uh, so after the 13th minute, buzzer will go. So it will sound something like this. Okay, so it will sound something like this. After that, within 2 minutes, you'll have to finish the presentations. And after that, again, Rajesh sir, Mahindra sir will take a 10-minute Q&A session, and then we are done. So please present your screen, and I'll tell you when to start. So at least try presenting your screen, one of you. So, Rajesh sir, is the screen visible to you? If yes, then we can proceed.
Yeah, we can see it.
No. Okay, okay, so okay, great. I'll give you the cue, team. Then you'll have to start. Okay. So you can start in three, two, one, go.
Time appropriate greetings, everyone. Myself, Aryan, and I'm here to present Team 11's submission walkthrough for the Digital Alpha's SEC filing analyzer for SaaS companies. It's our product finance. And we'll just jump ahead on the solution right away. So we looked at the problem space, and then we determined that we are essentially trying to create a financial research product. And the core of its content will be coming through the SEC filings data. And we created 5 key features which would anchor our product, and that would firstly be the marketplace itself. It would be a comprehensive list of all of the SaaS companies. It would include the key metrics of all of those companies. We created a dedicated dashboard page devoted to each company and their own specific metrics, as you can see. With this, we also created a watch list section where you can perform comparative analysis on watch lists which you have created for yourself, with the help of which you can track sectors, you can visualize information, and take context-specific decisions from your end. We also created a filings page where you can view specific filings. We try to include section-wise summaries. We have created QA-based snippets, as well as the entire filing itself based off sentiment-based highlighting. With this, we have also finally added a very, very comprehensive search and filter based section in which you can search your filter based filings using filing types, duration, and data filing, as well as the company it's associated with. With the solution overview, I would like to move ahead to the solution architecture. We used industry-specific product cycle with our own product design, product development, and analytics team, in which the first part was the product design, where I come in which we first explored the problem space. We interviewed a product analysts from our end. After that, we ideated an information architecture which would both include the guidelines for the problem statement as well as user QoL features and stakeholder requirements. And after this, we finally created our own visual design system for the product itself. With this, I would like to hand over to the product development team.
Yeah. So if you see at the left hand side, you can see that we have used React for our front end. So whenever a user comes onto our portal, he would be interacting with the front end. And when he interacts, then the front end would need to fetch some data from the back end, right? So that's being done through RESTful API calls. And the library that we have used in the front end is the HTTP Axios library, which does these API calls. Now, if you follow the cursor, you can see that for the backend, we have used the Python-based development framework called Django. The reason behind choosing a Python-based framework was because most of our analytics scripts are written in Python itself. Therefore, it would be easy for us to import or like include a script of the analytics script inside our backend itself. So now the Django backend is going to fetch the request data from the Postgres database, and then this data would be serialized by the serializers into a JSON format, which would be then sent over the network to the front end, and it would be displayed to the user based on the particular use case. Now, if you go to the next slide, yeah. So here you can see on the bottom of the screen, you can see a small pipeline of how the data, how the metrics are being generated, and how the sentiment and summary analysis is being done. Our analytics team will talk into more detail about it. But once we get this data, we have written Python scripts to automate the insertion of this data into our database. Therefore, we have reduced the manual effort. And let's say in the future, if you want to add, let's say, another KPI or another company, then we can easily run this script and there won't be any need of any manual labor. So yeah, so that's the development part. So with this, I would like to hand over the presentation to the analytics team, which will tell you more about how they have actually calculated these matrices. Okay, so thank you, development team. As shown in the bottom right section of the slide, we've got a systematic pipeline via which we derived all the required data which was used by the dev team. First of all, we extracted the CIK numbers of all the SaaS companies which were provided to us in the problem statement. Then we used an open source toolkit called Edgar Crawler, which is primarily used to extract 10K and 8K filings from the Edgar database given the CIK number. We modified the code of the same to include 10Q filings as well. We received JSON and HTML data from the crawler, which parsed which was parsed using Python scripts to extract tabular data, which was mainly from the item 8 of 10K and item 2 of 10Q filings. 8K filings was used for text data mainly, which was analyzed using NLP techniques, which will be discussed later. Fill up, uh, there were other some empty data points in these tables as well, which we filled up using reliable third-party financial sources. uh, we conducted next slide, yeah. We conducted some research on all the relevant metrics which are crucial to judge and assess the health of a SaaS company specifically. We tried to keep the list as exhaustive as possible, with some help from the hints that was provided to us in the problem statement and after as well. We also included some non-SaaS specific metrics like the assets, the liabilities, shareholding percentages of public and private, then the debt ratio, etc., which weren't exactly SaaS specific metrics, but are an important measure of the health of any company, be it SaaS or not the SaaS company. We can here see CAC, the customer acquisition cost, which is calculated by dividing the sales and marketing cost taken from the tabular data from the item 8 of 10K filings and item 2 of 10Q filings, divided by the number of customers data. Then there's gross margin percentage, which is calculated from the numerical values present directly in the tabular data I mentioned before. Then there's the ARR and MRR and the ARPU, which is the average revenue per user. And then there's product qualified leads and penetration rate, which are respectively the position of the company relative to its competitors based on revenue and customers, respectively. And then there are other metrics as well. As we can see here, most of the metrics required customers data, which wasn't directly available in the table. They were hidden in the text of the filings, which was extracted using NLP-based methods and scripting, which will be discussed in detail by my colleague from analytics team, to whom I will now hand over the presentation. Thank you.
Okay, yeah, thank you very much. As Gitanjit mentioned, there are three types of metrics that were available. First one that were directly found in the tables. So for these metrics, we were not like directly, we could not extract directly from the tables we had because the first of all, the name of the metrics were very different. Even if the metric was same, then the names of sheets were very different. So for that, we had to write detailed Python scripts to extract those metrics. The second type of metrics that were not available in the tables were available in the text. As we know that the filings 10K, 10Q are very voluminous. So what we did was we wrote down a regex pattern. We searched for it in the 10K and 10Q filings, and then we shortlisted paragraphs and sections on which we applied question answering models then to extract the metrics. So for an example of this is an example of Zoom videos. The text is as of January 31, 2022, 2021, and 2020, we had approximately 509,800 467,100 and 81,900 customers respectively, with more than 10 employees. When disclosing the number of customers, we round down to the nearest 100. When we ask the question, what is the number of customers in 2021, to various models, including Distilbert and Roberta, different models gave different answers with different confidence scores. And after doing thorough analysis of different models, we found out that the Roberta model was doing well according to our needs. So for retrieving the data that was in the text, we used Roberta question answering model, and there were metrics that were neither available in the text nor in the tables. So for that, to procure those metrics, we have used reliable third-party platforms. coming on to the next slide. Next slide, please, Aryan. Yeah. So sentiment and summarization was also an important part, which was all text driven. So as I have repeatedly said that 10K and 10Q filings are very voluminous, and just to give context, they are about 200 pages long, an average 10K filing. So for the investors or for the users of the product, effective summarization is very important. And keeping that in mind, we used BART large CNN model to train that. And for the filings, there are about 15 items in 10K and 10Q filings. We have provided item-wise summary for all those. And for an investor, uh, to invest, a sentiment is very important. Like if a bad sentiment is there, the investor would hesitate to buy the stock. So for that, we have done sentiment analysis, and 8K filings are specifically for that. So we have used Finword to do the sentiment analysis, and the most impactful and positive parts have been highlighted with dark green color, and the most impactful and negative parts have been highlighted with dark red color. And there's a gradient for less impact and negative. There are light red color and so on. So that was sentiment and summarization. So this was the walkthrough of the product that we have built, and now Arun will give you the demo of the product.
Thank you, Pranav, for the insightful comments. I'll just be able to share the product itself. Just give me a second. Okay, so as I've told about the solution architecture beforehand, so the entire team sat through and we went through 2 to 3 prototyping stages. We created the flows and everything, but keeping the submission period as well as the time period into account, we decided to condense it down further and try to create a demo piece with most of the features as working as they are. And with this, I would first showcase the marketplace in of itself and the homepage for the company section, where you would have the companies listed out with some key metrics showcased here, which we can view on our own. So let's just have a look at ADP for instance. So, okay, for here. So for ADP, let's just have a look. And for example, like I'm over here sitting at just like the total revenue set for automatic data processing. And you can see, have a look at the total revenue, or you can check out the total number of customers as well. We have also included an option to download the stat CSV for yourself, so that you can integrate it with any kind of other Excel-based systems which you have set up beforehand. And something else which I would like to showcase, and we are very proud of to showcase, is the watchlist section. So, for convenience, I've just went ahead and created a watchlist right now. More money, more problems. It has about 6 companies in it right now: HubSpot, MongoDB, Paycom, Software Inc., Palantir, SSMC, as well as ZoomInfo. So the key behind this was to let you select as well, let you select a few companies within your watch list so that you can compare. You can obviously select them all, but if you want to select a few, and then you can go ahead to do so. Let's just select HubSpot, MongoDB, Paycom. Let's just take ZoomInfo as well. Okay, so upon clicking on visualizing, it collects all of the metrics for all of these companies, and then you can view them as time progresses, like from December 2020 to December 2021. You can have a look at the total revenue or the total number of customers. Looks like HubSpot is really doing good, I guess. Okay. And after that, you can have a look at the ARR set for the entire metric as well. Finally, I would like to draw your attention to the filings page itself. Over here, this is the 10K filing for Okta Inc. So this is like a random filing snippet which I'm showcasing. So over here, you'll first have a look at the snippet. And over here, based off our user interviews, like what kind of questions usually product analysts look at, the QA model, which Pranav talked about beforehand, was implemented to find answers of questions and such. We also included the sentiment highlighted filing document completely, as discussed beforehand. And finally, the summary section, in which the entire items were summarized, and they made sure that they conducted most of the information. With this, I would like to conclude our presentation in of itself. We have showcased what the demo held, and this is Team 11 signing off. And with this, we are open to questions from the jury as well. Thank you for your time.
Okay, thank you. So the 10-minute presentation duration starts now. Rajesh sir and others, please.
Yeah, that's a very good presentation, Team 11. If we go back to where you've shown the filings and highlighting of the filings, can you talk about how you went about highlighting those filings? I think in the demo you showed the filings.
Yeah, Aryan, can you open maybe the website? And yeah, so basically what we did with the sentiment analysis for filings is that we parse the filings, so we break it into chunks. So the filings are naturally separated by paragraph tags. So we extract the text from the paragraph tags, and then we run a sentiment analysis pre-trained model. So for example, Finbird, and then we get a polarity score. So Aryan, it's in the filings document, I think. Yeah. So we get a polarity score for each paragraph, and then this score indicates how positive or how negative that paragraph is.
Yeah,
So
like I see. So the one, okay, these green markings basically means it's
yeah,
positive.
yeah.
But how did you actually like you use some sort of a tool to highlight it, or
Yeah. So basically, these forms are HTML forms, right? So we are just inserting highlight tags into the forms itself, and then rendering the HTML in the website.
okay, cool.
So the more green it is, the more positive sentiment, and so the
And do you
shade.
also have a score next to each of those highlightings? Like where let's say if someone wants to quantify this sentiment, right? So it's negative or it's positive, but how much negative, how much positive it is, and how do we compare it historically? Let's say if we were looking at expand our channel partner ecosystem, and that marked in red. How do we
Okay.
know, like historically, how this thing changed for this particular topic?
Okay, so for the sentiment part, we don't have a graph specifically which compares it to historical data because it's hard to pinpoint which like link each of the same paragraphs over multiple filings. But yeah, the shade is representing the polarity of the sentiment, and maybe in the future we can add a graph which shows the evolution of sentiment with time.
Okay. And the previous, the snippet tab, like, sorry, not snippet, I think maybe the filings, where you had
Summaries.
that item one, oh, summaries, yeah.
Yeah.
So this item 1B, item 2, item 3, what is this point? This is pointing to the actual filings where you have that red and green markings?
No, so this is actually the section-wise summary. So the filing itself is broken down into these 16, 17 items, right? So for
Okay.
each of those items, we are running it through a summarization model, and that model outputs a shortened text of the whole section basically, and then we are displaying it here. So if an investor doesn't want to read the whole section, they can just go over the summary over here.
Okay, but for that summary, since we are talking about, SEC filings and financial kind of terminology, what kind of model is used to summarize it? How
Yeah.
accurate?
So we are using Finbot to do the sentiment analysis, and for summarization, we are using Bartlar's CNN model. So these are specific to finance data. So they we noticed that they are providing good results, and the summary actually incorporated the metrics that we want to remain in the summary. So the important parts are kept in the summary itself, and no major data is lost.
I see. And when you're using these models, you're using these models as an API. Are you kind of hosting these models in your code base, or you're calling an external API?
No, these models are not hosted as an API. We actually did it like we generated the summaries separately and then stored them, and then we are using the data as an like we are calling the data from the API. So
I see.
basically,
So,
it's not live.
so it's kind of some sort of a batch process that you're
Yeah,
running.
yeah, yeah, exactly. So it may take time for the model to do the inference, right? So we didn't want that delay to occur. So we basically pre-ran all the data and then stored it.
Okay, okay. And in terms of extracting these metrics, like if we go to your like the main dashboard where you had, or maybe actually where you had a number of metrics and you were showing the graphs, right? So
Mhm.
yeah, this one. So this ARR, MRR, ARPU,
Hmm.
how did you extract these numbers? Like some of them are calculated values, but let's say for example ARPU or MRR expansion, for example, how did you get that one?
So basically, I think Gitanjit can elaborate more on this point as he works.
Yeah, so MRI
And
expansion is
sorry, number of qualified leads as well, because Number of qualified leads, I don't think we gave that metric, but it's an interesting metric. So I just want to learn what was the
Yeah.
methodology that is used and how consistent are these companies in reporting something like this.
Yeah, so for a number of qualified leads, actually, it was not exactly available. Like it's a sort of a guesstimate that we made to like scale the company in terms of the all the SaaS companies. We actually mentioned in the report the source from where we got the markets cap of all the SaaS companies, like on the US based SaaS companies of the world per year, and then we divided the total revenue in that particular quarter, for example, divided by the total market cap, like the total revenue that the company, being a SaaS company, could have got, divided by the total revenue it got divided by total revenue it could have got. Similarly, for the penetration, we used we didn't actually have the total number of customers. Like no one gives the total number of SaaS customers. It's like not a particular value which we can actually calculate. So we made a guesstimate. We looked at how many SaaS companies are present, like US based SaaS companies are present in the US market, and how many total customers on average use a SaaS company in a year. And from these two values, we made a guesstimate of how many
Yeah.
SaaS companies, how many customers may use SaaS companies as a whole in a particular quarter. So we
Okay.
divided the number of customers to from this value which we got from a guesstimate.
Okay. Yeah, that's
These are
fine.
the all
So
data which we got from Google.
what are the other data sets other than, external data sets other than SCC you've
Yeah.
used for some of these
Uh,
metrics?
so actually, this was not like we didn't exhaustively use like other sources, but wherever required, we used financial freely available financial sources like Yahoo Finance and MarketWatch. Like from Yahoo Finance, for example, if we didn't get the total sales and marketing costs from the item 8, then like if there was a 9 value in our CSV file, then we filled it up using data scraped from Yahoo Finance using Selenium.
Okay. And can we look at your data model? What does that look like?
Uh, Data model in the sense
How you are like I see the Postgres, the tables. Okay. No, no, never mind. I see what you have. Okay.
yeah. Actually, we have provided that in the repo as well in
Okay.
the like backend.
Got it. Okay. Cool. That's it from me.
So we have only 1.5 minutes remaining for the Q&A. So if any
Uh,
other panelists.
just maybe really quickly on the sentiment analysis where you do the paragraph by paragraph analysis. Have you come up with an overall score for a company based on that? Like how, if you had to say for the company, you're going paragraph by paragraph, is there a methodology you have for combining all of those sentiment scores into an overall score?
Yeah, the model, what it does is, along with the polarity score, it also gives a confidence score. So the confidence is basically how sure it is about the sentiment value it's assigned. So maybe for combining all the polarity scores, we can filter on the confidence, like say greater than 0.9, and then take an average of those polarity scores to get an
Right.
overall picture of the company's sentiment.
And have you thought about where this is going? Do you foresee that maybe you could see any correlation with future performance based on that? Have you done any work with regards to that?
No, since we used all data up to 2022, so we haven't looked into how it would correlate to
How it
future performance.
correlates with the stock price? Okay,
Yeah.
interesting. A good presentation.
Okay.
Thank you.
So we have, the time has ended. So thank you, team. Thank you for the presentation. So you can stop presenting now. So the next team in line is team 8. Team 8, if you're present, please raise your hands. Uh, uh, yeah, teammate is there. So, okay, I've handed the mic to Ian, then Shreyas as well. So, Ian and Shreyas, are there no other members from your team coming? Shreya, sorry, I'm very sorry, Shreya. Are there no other members? Okay, Saurabh has also raised his hand.
Yeah, then
Handed the mic.
there's Ayan, Aryan, Divyansh, and Saurabh.
Okay, so Saurabh, yourself, and Ayan have already received the access. So please have the others raise their hands as well.
Aryan and Divyansh.
So are they coming? Okay, Aryan is here. Uh, yeah, given the access. Uh, Anybody else?
Divyansh is having
Divyansh,
a
right? So
problem.
Divyansh is not here yet, I guess. You're not audible, Shreya.
Divyansh is facing some technical difficulty
Okay.
and he'll be joining in a
Okay.
few
Okay.
minutes.
Okay. So I think we can start with the presentation, right?
Yeah, just a minute. I'll share
Okay.
the
So
screen.
yeah, please share the screen. So I'll just mention the modalities once. So after the 13th minute, we'll ring a buzzer. It will sound something like this. Okay. So after this, you'll have to wrap up your presentation within 2 minutes. And then judges, uh, including Rajesh and others, will ask you some queries. Okay, Divyansh is here. I'll hand in the mic. Okay, Divyansh is here. So then there will be a 10-minute Q&A session, and then we are done. Okay. So please present your screen, and uh, I'll mention when to start.
Divyansh has requested to be made a presenter.
Yeah, I have given him the access, I guess. So yeah, Divyansh is here. Yeah. So please try presenting your screen, and can someone confirm if it's visible or not? Maybe uh, Rajesh or
It's visible.
um,
Yeah, we
Mahendra
can
Singh
see.
sir. Okay. Thank you, sir. So team, you will start the presentation when I say. So the timer will also start at the same time. Okay. All the best. So 3, 2, 1, go. The timer has started.
Can you
Please go.
present? Yeah, so good evening, judges. I thank you for giving me this opportunity to present our solution to this problem statement. So let me begin with the problem statement itself. In today's world, there are a lot of companies that provide software as a service and are known as SaaS companies. Now, since the past few decades, the market for SaaS companies has grown exponentially. And due to this, there is massive competition between these companies for growth. Amongst this, it is very important for shareholders and researchers to be able to analyze the health of these companies. Since SaaS companies are mostly customer driven, a set of metrics indicating customer response can be used to analyze the health of a company. But the catch is that these metrics are not readily available on publicly reported SEC filings and need to be analyzed from the available forms. These forms have been collected by the US Securities and Exchange Commission and are available for public disclosure on the Edgar database. This database contains hundreds and thousands of SEC filings from as early as 1993, spanning terabytes of data, and is thus very difficult for researchers to analyze. So we developed a tool
to help a person analyze these forms easily. The application has a user-friendly interface and is very easy to use. Our application displays the information obtained from the SEC filings of a company, that are the metrics and the goals of the company, in the form of graphs and charts, making it a lot easier to interpret the filings since the user does not have to go through each filing manually. We also developed a machine learning model to extract sentiments from the filings so as to provide the user with additional useful insight into the data. The details regarding the front end of the application and the machine learning will be shown later. Now, for the problem background, the Securities and Exchange Commission requires public companies, certain company insiders, and broker dealers to file periodic financial statements and other disclosures. These are called SEC filings. So basically, they are basically regulatory documents that companies and issuers of securities must submit to the Securities and Exchange Commission on a regular basis. The purpose is to provide transparency and information to investors, analysts, and regulators. Finance professionals and investors rely on SEC filings to make informed decisions when evaluating whether to invest in a company or not. Now, over to Shreya.
Hello. Analysis is primarily based on three types of SEC filings that provide most of the key matrices of the SaaS companies. These are first Form 8K, which is a report of unscheduled material events or corporate changes at the company that could be of importance to the shareholders or the SEC. The second is Form 10K, which is an annual report which consists of the financial condition of the company. The third is Form 10K, which is another comprehensive report of financial performance that must be submitted quarterly to the SEC by all public companies. Now, out of all these filings, we extracted data uh, regarding the following matrices. First is acquisition, which shows how efficient and predictable is the sales funnel. This included qualified leads, new accounts, conversion rate, sales cycle, and customer acquisition cost. The second metric was engagement and retention, which showed how much customers love the platform. This contains active users, NPS scores, which is a score given by the user review, and market penetration by the company. The third metric was revenue and growth, which shows how much are customers willing to pay. This consists of annual recurring revenue growth rate, monthly recurring revenue stats, quarterly recurring revenue, and average revenue. And the last metric was unit economics, which shows how healthy is the platform as a business. This consists of lifetime value, customer acquisition cost payback, and LTV to CEC comparison. Now over to Saurabh, who will show the application flow.
Um, Good evening, everyone. So now I'll quickly share the flow of the application that we built. Shreya, could you share this? Could you share that tab? Yeah. So our application provides an intuitive way for any user to query and analyze the key SaaS matrix for any given company. So as you can see, this is our solution that we built over the duration of the problem statement. The solution contains of three distinct layers that we have explained here, which are the client, the server, and the compute engine. Um, we uh, we have accumulated all the um, data into a format which is very easy to visualize and basically enables the user to make sense out of the visualizations. Um, so the primary feature that we have here is the global search, in which the user can either search by CIK number or the company name itself. On searching for the company name, we display all the key SaaS metrics in a visualization, which is easy to interpret. We have the top level SaaS goals and the sentiment analysis. We have the metrics for important metrics for the duration that we have selected. By default, we show the data for the past 5 years, but we have the ability to show the data over a custom time range as well. Um, we also have multiple visualizations which enable the user to analyze and pinpoint the data at every given quarter. Um, A user can perform three possible broad categories of operations here, which are fetching company metrics and displaying the trends, downloading the company data points, and comparing different companies. The client actually receives all the data in the form of GraphQL queries and suitably displays the data to enable maximum data consumption. As you can see here, we have the functionality to export all the data into a CSV file, and we can save it and view the company data on our local machine. We also have the feature for comparing the analytics for a given company with a different uh, company. Let's say I select the second company here, and so we get the visualizations and the UI, which basically enables us to compare the key data points for each and for both of the companies in a very comprehensive way. We also have the time range filters for this particular page as well, wherein we can decide the time range for which we want to compare the data for the given companies. Yeah, now coming back, so we can move to the next section. Yeah.
Yeah, so a warm good evening to everyone. So I'll be explaining the technical details about the architecture which we have built over here and how it scales depending on the solution. So before explaining this, I would like to point out a few key points which we had to take in consideration. So when we first ran our parser and the model to fetch the metrics for all the companies, we had over 8,000 data points spanning across 290 companies, which as you can see is a very huge amount of data for us to handle in a single point. So we decided on a few things that we wanted to implement and a few key features and frameworks that we wanted to use. So two of those are a GraphQL query and a NoSQL database. So I would now explain how the three parts of our architecture work. So the three parts include a client, which is a React-based front end, as you saw earlier in the application flow. The second part consists of a server, which is written in Flask and provides GraphQL endpoints for us to query data. And the third part consists of our compute engine. So I'll be starting with the compute engine first. So the work of the compute engine is to parse the data from the SEC filing. So we use Beautiful Soup for that and Python parsers for CSV and stuff, so that we can extract data from the tables which are there in the SEC filings and then parse them through and find out the relevant metrics from them. So once we find these out, we send them to a NoSQL database. We have used Mongo over here, but we can easily switch it over to Cassandra or other databases which scale more with the volume of data which we have. So once these SEC filings are passed, they are sent to the NoSQL database, which then talks to our SQL, which then talks to a Flask server and tells them that the data is ready. So as you can see, both of these components are decoupled. So unlike some solutions wherein unlike some solutions, we don't parse these data in real time, but instead we parse them earlier and we store those data points in the database itself so that we can query them quickly, which saves on precious time when analyzing the data by any client or any researcher in future. The server then provides two things. It provides an access to the NoSQL data points, which is necessary because if we were doing this in real time, it would take a lot of time to like pass through all the SEC files for a given company, and if we change the date filter, it would have to do the same thing again. But instead, what we do is we provide you GraphQL endpoints. Why we use GraphQL over here is because of the volume of our data and the various metrics which we have. So GraphQL acts as the best solution over here due to the fact that we can only query as much data as we want, and the data computation is verified due to the nature of how GraphQL endpoints work. They generate a graph of all the data and maintain relations with themselves. The reason why we use NoSQL is because we were worried about the future implications. Say in the future the 10K or the 10Q filings change, we could have a lot more metrics than the current ones, and so NoSQL databases provide us with the method to change the schema of our data without having to worry about the past data getting destroyed. And again, we present them in the client, wherein, as you saw earlier, shows all the data which we have. Now over to Divyansh to explain how the model works.
Thank you, Ayan, and a warm good evening to each and everyone present here. So, our model involved three elements, that is the scraper, the parser, and the sentiment analyzer. For scraping, the data consisted of the various filings were downloaded using the SecEdgar downloader, which is an open source Python package for downloading company filings directly from the SecEdgar database. It downloaded the 8K, 10K, 10Q filing of all the companies, and it provided us the HTML form filing and the text file of that HTML form filing. It allowed for searching and retrieving filings either by stock ticker or central index key, which is the CIK of that company. Then the data is parsed to the parser. The parser uses the beautiful soup library of Python to parse all the filings and removing all the HTML tags to extract all the essentially clean sections from the form. The text part of the data is usually provided with tag of that filing name, like if the filing was 10K, then the type of that tag was 10K. And it was taken out for sentiment analysis of that filing, and the data in the tabular form, which was basically the important data for the matrix, which we had to present on the dashboard, was also extracted using beautiful soup, and it was exported as a CSV file using the pandas data frame and sent to the database. Now, before I proceed with the sentiment analysis, I'll give you an example. Shares of food delivery companies surged despite the catastrophic impact of coronavirus on global markets. Now, it is not an easy task for computers to extract this positive message because it requires understanding of what is positive and negative in the financial context without getting confused with the rest of the sentence. So, our initial approach towards sentiment analysis of SEC filings was counting positive and negative words in the corpus using Logran and McDonald Financial Dictionary. But it failed to understand the deep semantic meanings of financial statements because it only involved the counting of words which were present in a dictionary. And hence, we were not satisfied with the results as it was not that accurate. So we further approached the FinBERT or the financial BERT model. FinBERT is a BERT which is exclusively used for extracting sentiments of financial documents. For FinBERT, the author had first trained our BERT on Wikipedia and book corpuses to get the semantics of the English language. Then he pre-trained our BERT on a financial document, which was the Reuters TRC2 financial, to help the BERT learn the financial terminology and semantics, which could help us further for our sentiment analysis, because as we know that our model should know some finance language before we could use it for sentiment analysis. Now the author further trains this model on financial phrase bank, which are basically an annotated set of documents with each document labeled with its sentiment. And this trained a model for sentiment classification, like classifying the sentiment of this filing, whether it's positive or negative or neutral. The resulting model is a Finbert model with pre-trained weights, which we use to extract the sentiments of our SecEdgar filings, as the Finbert paper promised a very promising accuracy of 86%. Now, for pre-processing of our data, we searched for text in the appropriate filing type, 10K, 10K, or 8K in the scrapped text file, and removed all the unnecessary formatted tags, HTML tags, Unicode strings, multiple spaces using the regex library of Python. Then we tokenized our documents into sentences, and we passed this array of sentences of the filing, of the text file of that filing, to the Finbert model. We gave the sentiments of each sentence
Hello team, your time is up.
Finbert. A positive sentiment getting a sentiment score of +1, neutral of 0, and a negative sentiment of -1. We added the sentiment scores of all the
Hello
sentences
team, your time is up.
to get the
Just
final sentiment
informing, there
score
will be
of the
penalty if you go
entire
ahead.
document. Then we group the sentiments of all the quarters of a particular company by getting the sentiment from all the documents filed in that quarter by that company, and group them company wise in a CSV file using the pandas data frame, and which we send to our database to display on the dashboard.
So to summarize the work which we did, so our final vision was to give a product which provides all the data from the SEC filings in as intuitive way as possible, and to make it as easy for researchers to query that data, so that they won't have to waste precious time and resources on worrying about how they are going to pass data filings. And hence we developed a solution which has its own unique parts and features, and hence provides a solution which is highly scalable, highly modular, and can turn into the best solution possible.
So
And
please stop.
with this,
1 minute has
I
already passed
our
after the
presentation
deadline.
is at its end, and
Yeah.
we are open for questions. Thank you.
Yeah. So judges, please ask questions. The time for questions starts now. Sir, please. Mahendra
Um,
sir.
okay, let me. This is Mahendra. I'll ask a couple of questions really quickly. Good presentation. First question is, you're presenting a lot of data on your dashboard. It's a nice dashboard with a wealth of information. Are you supplementing this with additional data that you extracted from the filings? Can you hear me?
Yes, sir. We use the SEC file, the information extracted from the SEC filings, along with third-party data sources like Yahoo Finance.
Like Yahoo Finance. Okay. You talked about the scraper, the parser, the sentimental analyzer. But you also mentioned a compute engine. Is the compute engine different than the sentiment analyzer?
Sir, could you please repeat the question?
You spoke about the different components of your system, which is the scraper, a parser, and the sentiment analyzer. But in your presentation, you also mentioned the three main components: the separation of a compute engine. And I'm wondering, are those sentiment analyzer is different than the compute engine, correct?
So basically, that's not different from the sentiment analysis, like the scrape data, the beautiful soup library that removed all the HTML tag for us, and that pass data was sent to the model, and from there we removed all the unnecessary tags and Unicode from the regex library. So,
So what is the compute engine? What does that do?
Basically what we are doing, like first we scrape the data from our Edgar downloader, and
Oh, I see. I see. Okay, so it's
and
not
then
it's not necessarily an analytic computer engine. It's more of a process compute engine.
Uh, the compute engine has two parts. If Shreya, if you could go to the architecture diagram which we had. Yeah. So if you see over here, we have two parts of it. So the first part is a web scraper which scrapes data from the Edgar data source and other sources such as BAMSEC and the Yahoo Finance. And from there, once we get the data source, we extract all the data from it. So as Divan told earlier, we use the particular libraries for it, such as beautiful soup and stuff. And we take out the content from the tables and pass it separately, and we take out the text and pass it separately. So the text then goes to the sentiment analyzer, and the tabular content goes to the ML model. Both of these in the end up in the ML model and are trained using that. The first reason being, for the text we need the text entirely for the sentiment analysis, because we need to find specific words that the Finbot model uses. And for the metrics, we need to see the specific data sets which are there. So there were many data points which did not show users as daily active users, or did not show users as active users at all. They gave some different numbers, such as we had these many people coming onto our platform. So we had to find data from those metrics as well, which required the use of an ML model. So the compute engine is a compute engine, not a parser, basically, because it uses both the ML model as well as the scraper, and that's why we decided to name it a compute engine.
Okay, good. All right, all right. Thanks. You answered my question. I was looking for, in your report as well as in your presentation, you emphasized the compute engine, but I couldn't find anything related to that in the GitHub sources. So from what you're saying, it's basically a combination. What you're referring to as a compute engine is both the ML and as well as the process of parsing. Am I correct? Okay, that's all I have.
So when extracting these SAS metrics that you were showing in the initial dashboard, do you have coverage metrics like out of the 135 universe? like how many companies you were able to basically get some of these metrics, let's say CAC or LTV or AR, like things like that. How many of them you were actually able to get from that 135, and what are like the challenges that you ran into when you try to extract the numbers out of the text, and what kind of accuracy you were able to achieve?
For these metrics, the SAS metrics, so I'll start with the challenges first, and then we'll go on to what the coverage we had. So as I told earlier, that for many of the companies, we did not get the user data directly. They were very obscure in the text over there, and we had to rely on like the accuracy of a model for fetching the user data, and also on third-party sources for that. So fetching the user data was a very big problem for us, because a lot of the other metrics depend on those. As for the coverage, we decided that why not extend it to not only those 135 companies, but to go higher than that. So we decided to target a corpus of 292 companies, and we succeeded in getting data for like over 250 companies. So because we wanted this to be a fully scalable solution that could be used by researchers, and we have also hosted it so that it could be open for public use rather than be just for the sake of this hackathon. So our coverage rate is very high regarding that, because we went over and further what we were asked to do. Other than that, the accuracy of an ML model for Finbert is 86%, as Devansh told earlier, and for the data metrics which we have, it's closer to 92.4%.
Okay. And like your database, like how many metrics are you storing, like including the standard financial statements and SAS for each company? How many metrics do you roughly have?
So the metrics that we roughly have, so if you could go to over to a dashboard, we show all the metrics over there. So we have a total of 4 SAS goals, plus a sentiment analysis, and if I'm correct, we have 15 metrics in total for a company, except those. So we'll just show it over to you over there in the database. So
Do you
once
also
it
have
loads up.
are you also getting the standard income statement,
Yeah,
balance sheet, and
so as
cash
you can
flow?
see, we have 5 of those the 5 of those stickers over there. The 4 growth, profitability, maturity, and retention are the key SAS goals. The sentiment is over there. Then we have 5 charts in the first column, and then we have another 3 on the side. We have 4 on the side, 3 on the middle, and another 3 on the side. So it's like, yeah, a 4 is 7, 10. Yeah, we have 15 metrics, and then another 5 of those ones which come from the sentiment analysis of the text.
Yeah,
So
I mean
it's a total of
that's what you're
20
showing here,
metrics
but
for
I'm just
each company.
wondering, in the database, are you storing like the metrics from the income statement, balance sheet, and cash flow as well, in addition to the SAS metrics?
No, we aren't storing those metrics over there. So whatever data which you see over there is the ones which we have stored in the database, because we thought that, because as I told you earlier, we already had plus over 8,000 data points, and it was already tough to handle and manage such a quite large database. So we decided for present we'll be restricting ourselves to this data, but if needed we can save other data points as well. It is not a restriction on our side, but we decided that it is better if we restrict ourselves to these 20 data points rather than
Oh,
expanding more, because
okay.
again, as I
What
told you
other
earlier, we
data
had a lot of
sources
data
did
points
you
to
use?
handle, and it was getting.
What are the other external data sources you used other than
So
SCC file?
yeah, so for those data sources, the first one, which was a very big help, is the Yahoo Finance API. But again, the Yahoo Finance API also had changed their API format over the years. Like, we were getting a lot of documentation from 2015, but they
One
nuked the API in 2018 and had a new API in its
Okay.
place. So we had to write a
You
lot of the
mentioned
parser for the
BAMSEC.
Yahoo Finance API on our own, which
Sorry.
is like our own original work.
Yeah, I
Apart
am
from that,
one
we also
second.
use the BAMSEC API filings
Yeah, what
and
were you
the
using BAMSEC
Edgar
for?
data. Yeah.
What were you using BAMSEC for? What were you getting from
So
BAMSEC?
yeah, so a lot of the time the Edgar data source was like blocking a request, because it has that user authorization error, because if you don't have the correct authorization credential, it does not let us download data in bulk. So for that, we were using BAMSec, which allowed us to download a lot of data in bulk and did not pose those restrictions on us. So we had to use BAMSec for that. We used Yahoo Finance API for a lot of things, and we also use the ticker and the ticker to symbol text for dot. There is a ticker.txt file in the Edgar database itself, which is a globally recognized, which the SEC file, SEC site has published on their
The
website.
time is up for
So we
the
use that as well.
session. So yeah, I
Oh,
was yeah, yes, the time is
okay.
up.
Thank
Yeah.
you.
Thank you, team. So you can stop presenting. Thank you for the presentation.
Thank you.
So the next team, that is team 10, you can raise your hand. I'll try. I mean, I'll make you the presenters. Team 10. Okay. So yeah, I've given the rights to all the people who had raised their hands. So team, you can try presenting the screen. Uh, and in the meanwhile, I'll just tell the modularities. So so we have 15 minutes of presentations, and after the 13th minute, a bell will ring, which will sound like this. Okay. So after this bell rings, you'll have to complete your presentation within 2 minutes. After that, Rajesh and other panelists, Mahendra Singh sir and other panelists will ask questions. So you can answer them for the next 10 minutes, and then we are done. So I hope the team is ready. If you want to do any checks, you can. Else, I'll mention when to start. You can start.
Am I
Give
audible?
me any- Yeah, yeah, you are.
Okay, fine, cool.
Okay, okay, fine. So I'll mention when to start. You can start up now. Okay. So team, you can start in three, two, one, go.
Good evening, everyone. Today we are here to represent Team 10 and present to you the solution of the SAS analyzer problem statement. Talking about the problem statement, we were required to build an easy-to-use filing analyzer to evaluate the growth of particular SaaS companies based on certain metrics. And here is a solution to it. On your screen, you can see a raw screenshot of the hosted application, which is hosted on an AWS digitalalpha.ml. Please do check it out. Talking about the web app architecture. In the web stack, we have used React.js as our front-end framework, Flask as our back-end framework, MongoDB as a database to provide scalability to the model and also to ease the pre-processing of the data. We have also used a third-party API known as the SEC API for extracting the various filings and their respective sections in text format. Talking about some of the features that our application provides to the users are it provides a competitive comparison in which the user can compare side by side two companies based on their SaaS metrics. Next, it provides the SaaS metrics classification in which the SaaS metrics of a particular company are classified as good, bad, or neutral depending upon certain values. Number three, it provides us the table of content which segments the huge SEC filings into number of sections for the ease of user navigation. And number four, it also provides a utility to export the data set in the CSV format. Now, why should we use this analyzer? You should use this analyzer because we have made use of the recent advancements in the field of machine learning, particularly in that of natural language processing, to enhance the financial evaluation of the SaaS companies. Now, some of the features that make us stand out of the competition are the sentiment analyzer. In the sentiment analyzer, our application analyzes the sentiments of the various companies, which then presents this under different labels. It also tells us about the financial condition of the company. Next, the Twitter trends, in which we scrape the recent 5,000 Twitter activities of the company, which tells us that whether the company has been in recent talks or not. Next, we have implemented a summarizer, which summarizes the huge chunk of the SEC filings in a small and readable format for the ease of the user. And an FAQ generator, which generates relevant questions and their answers based on the SEC filings of the companies.
Now, as we move to the financial aspect of our solution, SaaS companies have a unique business model as their business is completely dependent on how their relationship is with the customers. If the customers are content with the SaaS services, the company shall be more profitable, which will eventually result in higher customer retention. And the SaaS business focuses on three major things: acquiring customers, retaining customers, monetizing customers. As they come up with such strategies that will attract customers toward their services, then retain the customers for long periods, which upgrades and accelerates their profits. Here we have enlisted all the matrices and fundamentals which we used on our dashboard that helps the user to evaluate the SaaS business. Now question arises why we need metrics for SaaS business. Metrics play a very important role in understanding and optimizing a SaaS business. Metrics answered a list of the following questions. They tell us how financially stable the business is, what things are working and bringing fruitful results, and what are the areas where the team management should focus on, and how accelerating the business is in the terms of growth. After going through SEC filings, business reports, and models, from the long list of metrics, we sorted out some of the metrics which will cover up each aspect of the business. These metrics will give a clear indication of overall performance, growth, sales, profitability, and efficiency for any SaaS business. So here we highlighted the main key SaaS metrics and also the reasoning behind selecting these specifically. NRR is the recurring revenue retained from existing customers. The higher NRR indicates customers are showing interest in the services and are more likely to repeat that. Payback period indicates time taken by customers to pay back their CAC. It also indicates the capital efficiency of business. Shorter period indicates that the SaaS business growth is good. CAC tells how much the SaaS business is. Investing in acquiring new customers, building and maintaining an accurate and dependable CAC is key for the sustainable SaaS growth. Magic number metric focuses on the sale and market element of SaaS business and tells how much the sales and marketing investments are successful. The 3:1 LTV to SaaS ratio is considered good, and if the acquisition costs are exceeding the norm, then AR tells how much revenue a company expects to repeat. It tells about momentum gain in areas such as new sales, renewals, and upgrades, and loss of momentum in downgrades and lost customers. It also indicates the company's progress and helps in predicting future growth.
Now we will discuss various machine learning algorithms we have implemented. Our first model is the metrics finder, which finds the value of a metric given the company name and starts and end date. The pipeline consists of the given six processes. These are explained in the following slides. We use the full text search endpoint of SEC API, passing the metric name along with the time frame to the API to get the URLs of the filings that contain the metric name. The model then searches through all the filings, including 10K, 10Q, 8K, and all the press releases. Going through each filing, the model uses the corresponding parser to get its text content. It removes those sentences from the text that do not contain the metric name. Our window search algorithm then scans for the metric name in the filtered text. When the algorithm finds a particular occurrence of the metric, it spans k tokens to the left of the occurrence to k tokens to the right to get a list of phrases. We use named entity recognition to label the tokens among these phrases. If a type of token, say numerical value or ratio, matches the metric type, we add that token to a list of prospective metric values. We also have a question answering model. This model gives us an answer on passing a question and the text as the context. So we pass the filtered sequences as context and a question asking the metric's value to the model, which returns the metric value as the answer. A question may arise that why we have used the window search algorithm when we have the question answering model. Well, this is because the question answering model does not work well in case of large inputs. In order to handle this, we use the filings parser we developed to break down the filings into sections
and then apply the above algorithm section by section to generate the top key answer. Thus, the final value is the top intersection of possible values found from these two models, giving higher accuracy. We find that breaking the filings into sections and then using the Q&A model helps us immensely. We tested this model for the churn rate metric on the filings containing its value. It gave the correct result 9 out of 10 times. We performed similar tests for retention rate and various other metrics and achieved an accuracy of about 85%. Moving on to the sentiment analyzer, we have seen that an abnormal increase in the number of positive or negative words in filings can signal a significant change in the company's stock price in the upcoming quarters. So to capture this information, we have used the sentiment analyzer that uses the lexicon-based model. The model extracts section 7 of the 10K forms and searches each word in the sentiment word list. The list contains the words with a label representing the corresponding sentiment. The model then gives the overall sentiment score corresponding to 6 sentiment classes. We have used section 7 because it is the most crucial section containing management discussion and analysis of the company. One disadvantage of the lexicon-based approach is that it disregards context. So we use the state-of-the-art transformer model, FinBERT, which captures this vital information. This model was explicitly fine-tuned on financial data and achieved an accuracy of 97% on financial phrase bank dataset. The model takes section 7 of the 10K form and gives a highly accurate sentiment score for 3 sentiment classes.
Next is the Twitter Trends model. This model scrapes the latest tweets from Twitter and applies the LDA topic modeling method that finds the top N topics from the tweets. Here, K and N are hyperparameters representing the number of tweets and trends, respectively, which can be tuned to improve the model's performance. Since the model scrapes the latest tweets, generating the Twitter trends for some specific SaaS companies gives us an insight into the common discussions about the company amongst the users. Moving on to the summarizer. This model summarizes the lengthy Item 7 of annual SEC filings, which generally goes up to 30 pages and up to 3,000 words, into merely a single paragraph containing important information, allowing the user to focus only on the essential parts in this section. This model can similarly be extended to any other section. We have used the Legal Pegasus summarization model, which was trained on SEC litigation releases and hence gives us the best results for our test case. FAQs are an essential component of any dashboard and improve readability to a large extent. Therefore, we decided to use a Q&A generator on top of the generated summary. The summary as input will allow us to focus on only the crux of the section and therefore generate essential and valuable Q&As. We use a multitask T5-based model trained for question answering and answer-aware question generation tasks. This is a view of your UI that presents the generated FAQs. We have also implemented parsers for different forms. These parsers break down the lengthy SEC filings into separate sections, each of which deals with the different aspects of the company's reporting, making it easy to navigate. We also have a table extractor that uses pandas and regex to extract the tables from the filings. These tables present vital stats of the SaaS companies and thus can be used for further analysis. Now we'll proceed with the UI demo.
Now we'll begin with the UI demo. First of all, this is how a UI demo looks like. This is a sidebar for ease of navigation. It essentially have three features: search, compare, and export data. We'll first go to the search feature. Here we can type in a company name and get the data about the entire company. Let's type Zoom for instance. We get a suggestion as we type. We are fetching data from backend. Now you can see that it is the company name and the company ticker. The entire informations we have about the data is classified into four headers: overview, deep dive, highlights, and filing explorer. We'll be going through each of them one by one. In the overview frame, we first have a brief description about the company and what they do. Then, followed by that, we have seven key SaaS metrics which of the latest quarter. You would also observe that some of the key SaaS metrics have some borders around them. That represents good, bad, neutral classification of those same SaaS metrics. Next to that, we have sentiments provided by various providers under different labels. You would also observe that there are some placeholder with double dash. That implies that we don't have data, we could not extract data against that variable. Fine. Next to that, we have Twitter trends tag as displayed as explained in the presentation before. Finally, we have other financial metrics for the same company. Next section is the deep dive section. In this section, we have all the key SaaS matrices against the time series and plotted in a curve. And these graphs are divided into sections and subsections for a drill down approach. Now we'll go through each of these key SAS goals one by one. The first one is the growth. It has annual growth, which has difference in ARR. Then there is total customer. You would also notice that there are some data points missing. These are the data points that we could not extract during the extraction. Then we have revenue retention, in which we have net revenue retention. Then we have profitability, in which we have customer profitability, implied CAC, implied LTV. Then we have overall profitability. It has annual recurring revenue. Finally, we have payback. You would all now we can also filter these data sets according to a given time frame. Let's filter from 1st of January 2018. I'm sorry. Let's filter from 1st of January to 2018 to, let's say, last month. Right. You would see that these data have been filtered. Now we also have references to all those data. Let's say, for example, the total customers for Zoom is 509,800 in first quarter of 2022. Let's go and see the first quarter of 2022. Into the filing. This is the Edgar source, official Edgar source where we scrape data. We go 508,000 and 509,000, sorry. And we see the data here. Next, we have the highlights. It was explained in the presentation itself, where we have Q&A. Then the filing explorer, we have item 7 summary, and then item wise explorer, where we have each item explained from the file. Then we have compare. Let's say we compare Zoom and Alteryx, two companies. Here it is also very similar to the search feature, where we have overview, side-by-side comparison of all the key SAS matrices. Then we have deep dive. Here we have plotted two plots in the same canvas, in the same drill-down approach, in the similar fashion for ease of access. You can also browse through the data by hovering over them. And the filter works in the same manner. The final feature of the application is we can download the CSV format of each company. Let's say I want to download for Alteryx in the period of 1st of January, say 2015 to 1st of January 2016. And if I want to download this data, it will download as masterdata.csv. Just a second. This is the corresponding data of AYX in the given time. That concludes the UI demo. Thank you very much. We are open for questions.
So thank you, team. So the 10-minute Q&A session will start now. So Mahendra sir and Rajesh sir, the time starts now.
Okay, thank you for the presentation. Just wondering, like, can you talk about some of the challenges that you ran into extracting the SAS metrics, and what level of confidence you have on the accuracy of those metrics?
Yeah, sure, sir. So actually, as you can see, like this data is not uniformly available across all these filings, since these are non-GAAP metrics, and therefore it is not mandatory for the companies to actually mention all these valuable information in the filings. So initially, we started developing the model by only scraping the 10K, but as you could see, we had a very low coverage because all of the data is not essentially contained in the 10K. So after that, we decided to expand our approach and to search in other filings. And now with our metric finder, we actually search 10K, 10Q, 8K, as well as press releases. And we filter down our metrics using SEC full text search endpoint API, which actually filters down to the date, as well as to the company name, as well as to the documents which we want to search. And in this way, we cover all the press releases as well as all the filing documents in order to enable a full coverage of all the documents that a company releases. And as per the confidence, we've actually performed an out of sample testing for, like, let's say, retention rate. Like, let's say we had 10 documents in which the value was mentioned and we got a correct value 9 out of the 10 times. As well as for some other metrics, like ARR, etc., we achieved an average accuracy of about 85%.
Okay. And did you use any pre-existing models, like other than Finbert? What are the
Yes,
other?
sir. Yes, sir. So actually, for this question answering model, we actually use the base T5 model, which for question answering and question generation tasks, which was used from Hugging Face uploaded by Valhalla, which actually provides easy to use inference and deployment scripts. In addition to that, for summarization model, we actually use Legal Pegasus. Now, various other teams might be using Finbert or some other models, but why we use Legal Pegasus was that it was specifically trained on SEC litigation releases, and this is exactly the text which is there in the SEC filings, and therefore performs the best on the SEC filings, as it was explained in a GitHub repository when it was tested in comparison to some other models like Finbert or some other architectures.
Okay. And what does your data model look like for storing all this data?
Well, sir, our data model can be explained. So we use a MongoDB database. Now that could more be explained in detail by Pranay. So Pranay, I guess you can go ahead and explain the architecture of the database.
Yeah, so we were using MongoDB database, and we are like pre-processing all the data that we have obtained from the ML-based models and storing it into a database for faster access of the user. We also use a MongoDB database because it provides us greater scalability.
Sorry, this is unrelated to the database, but the news articles that you're scraping or like you're generating metrics from, is that from the filings, SEC filings, or you're going to external news sites to gather the metrics?
So for the news filings, we actually generate the data from the filings itself. So now actually, as you can see, we have some key metrics. Now those key metrics actually we are divided into two key sections, that is financial metrics 1 and 2. Now for financial metrics 1, we have three have key financial metrics with the help of which we can generate some other financial metrics. So for these three key financial metrics, we use the SEC filings to extract those values, and then with some other information like revenue, cash flow, etc. We were able to come up with all the metrics which we have in the dashboard.
Okay, thank you.
Thanks a lot, sir.
Do any of the panelists have other queries?
Sorry, I was a little distracted there. Just a quick two questions. You might have touched on this Windows search algorithm. That's actually you're using the Microsoft Windows search API.
No, sir. Actually, that is the name
What
which
is
we
that?
gave to our algorithm. So actually, what that algorithm does is that algorithm basically uses a very simple human intuition, which actually gives us very important results. So that algorithm basically helps us is that whenever a metric value is mentioned, it has a corresponding label attached to it. By label, I mean, let's say we have churn rate. So whenever a company mentions the churn rate, it specifies in a window of like, let's say K tokens to the left of the value, K tokens to the right of the value, the label churn rate. So that is specifically what our window search algorithm is. Let's say we have our metric churn rate, we extract K tokens to the right of the metric, and we extract K tokens to the left of the metric. After that, we use, yeah, yes, sir.
And is that what you're using for the highlights tab?
No, sir. So highlights tab is actually different. So our highlights
Okay.
tab is basically the Q&A. That is basically the Q&A model which we use. So the Q&A model is basically the model which we use, which actually this is a base Q T5 answer agnostic question generation model. Which actually what it does is that it takes in a paragraph or text as an input, and then it generates relevant text questions as well as answers as an output. So this is what the highlights tab is basically.
And so, okay, so and how does the highlight algorithm work? Is that also um, looking for keywords? Is that a machine learning algorithm as well? Or what is that?
Yes, sir. So actually, this highlights algorithm is in fact a machine learning algorithm, but it is a pre-trained model which we use. So what that algorithm does is that when it takes a set of text as input, it applies attention layer to this text and generates a probability distribution over all the tokens of the text, which could be the possible answers. Now, when we have the possible answers, it generates the questions from those answers in the second step, and the third step is basically combining them to generate the question answer pairs. So that is how our FAQ generator works.
I see. Okay, interesting. How accurate is that? That have you?
Okay. Yes, sir. So actually for this FAQ generator model, as I had said earlier, we use a pre-trained T5 based QA/QG model. And now when this model was tested on some other data sets, like this is a SOTA model basically. So like its performance is actually available publicly on the internet. So it has a rogue one score, if I remember correctly, of approx 43 point something on exam some data set which is specifically meant for this task. Yeah.
Got it. Got it. And just one last thing, not as important, I suppose, but you do have this Twitter trend tags.
Yes, sir.
Does that what exactly is that?
Yes, sir. So actually, the basic intuition behind the Twitter trends is that, let's say, whenever a SaaS company, or whenever, let's say, for example, a particular company does some major changes in its policies. So when it does that, it is going to affect the investors' belief in that company, because each investor has its own set of beliefs. So that investor must actually know what is if the company is actually news, because whenever a public company does some changes, it actually floods the Twitter with the tweets of those particular companies. So our Twitter algorithm, what it does is that it extracts some latest K tweets, where K is the hyperparameter value which we use from using a Twitter extract API. And once we have all this set of tweets, we perform LDA multi-core analysis, which actually helps in parallelizing the algorithm, as well as helping us to generate the models at the same time, to actually generate the top N models where N is actually a hyperparameter. Now for each model, we actually have 5 keywords pertaining to that model, and those are the 5 keywords which we display on the dashboard.
Okay, thank you.
So 1.5 minutes left for the discussion.
That's my no more questions from me.
Thanks a lot, sir.
Yeah, and I would request the judges to please check out our posted site, which is digitalalpha.ml. You might get it in the chat.
Yeah, thank you. But looks like for some of the companies, the data is missing, right? Like I was looking at, let's say, AlterX.
Yes, sir. Yes, sir. So actually, thing is that, like, we extracted all the data which we could get for all the 292 companies which we have in the list. So as you already know, like, those metrics, like, for some companies they are very sparse, for some companies they are easily available. So we applied our algorithm for all the
Like
companies.
for example, the filings explorer for AlterX, there is no content under item 1, item 2.
Yes, sir. So basically, actually, for this filing explorer, and basically for, like, let's say, for the highlights tab, which is basically the Q&A generator, and, like, let's say, for one or two more transform models, as you know, they are GPU extensive models, so they consume a lot of GPU space, and therefore for POC purposes, we had applied this model for only 330 companies that we chose as some sort of POC purposes, and not to all the companies. Whereas for the metrics, we displayed for all the companies that we do.
Okay, thank you.
Thanks a lot, sir.
Okay, thank you, team. Thank you for the presentation. So, with this, we come to an end to the set of presentations today. So, I thank all the panelists, especially Rajesh sir and Mahindra sir, for giving their time uh, to come and judge the teams. So, Azad also asked me to convey uh, heartfelt gratitude. He was, I mean, very happy that you could come and judge the teams. So yeah, thank you,
I'm
sir.
happy
Thank you.
to. Thank you for having me.
Yeah. Thank you, sir.
Thank
Thank
you.
you.
Thanks
Bye,
for
sir.
organizing
Bye.
this. Thank you.
Yes.
Bye, sir. Bye.
Yeah, bye.